Hello and welcome. I'm an ethical hacker, a computer scientist, and I'll be your instructor in this course. In this course, I'm going to teach you ethical hacking from scratch, so I'm going to assume that you have no prior knowledge, and by the end of it, you'll be at a high intermediate level. So we'll start by teaching you how to set up a penetration testing lab and how to install the needed software so you can practice hacking safely. Once done, the course is divided into 4 main penetration testing sections. The first is the network hacking section, where you'll learn how networks work, how devices communicate with each other, and how to exploit this method of communication to control all the connections around you, crack Wi-Fi keys and gain access to Wi-Fi networks, whether they use web, WPA or WPA2, and intercept data to capture usernames, passwords, chat messages, or anything that anybody does on the same network. Once done with this, we'll move to the gaining access section, where you'll learn how to gain access to servers and personal computers. So first, you'll learn how to gather comprehensive information about your target, discover vulnerabilities, and exploit them to gain full control over the target system. Not only that, but you'll also learn how to generate undetectable backdoors and use social engineering to deliver them to your target as a fake update or as a PDF or an image or any other file that they might be interested in. You'll also learn how to spoof emails, so when they're delivered to your target, they appear as if they're sent from a friend, from their boss, or from any address that they're likely to interact with. Once done with all of this, we'll move to the post-exploitation section, where you'll learn what can you do with the access that you gained in the previous sections. So you'll learn how to interact with the file system, how to execute system commands, record keystrikes, open the webcam, and even use the hacked computer as a pivot to hack into other computers. Once done with all of this, we'll move to the website hacking section, where you'll learn how websites work, how to gather comprehensive information about a target website, and how to discover and exploit a number of dangerous vulnerabilities that allow you to gain full control over the target website. At the end of each section, you'll learn how to secure systems and secure yourself from the discussed attacks. Now, before we dive into the course content, I'd like to give you a teaser or a taste of what you'll be able to do by the end of the course. So this is going to be one example that's based on one topic that's covered in one subsection of the course. Now, because this is a teaser lecture, I'm not going to explain the technical aspect of how am I doing this, because I'm going to teach you how to do this as you go through the course. For now, just sit back and enjoy this lecture, and after this lecture, we're going to dive into the course content, where you'll learn how to do things like this and much more. So in this video, I'm going to give you an example of hacking this Windows computer from this Linux machine. So in this example, I'm going to use a program called Beef, which is a browser exploitation framework. I'm going to launch it from here. And the way this works is it uses a JavaScript code to hook a target computer, and then once a computer is hooked, we'll be able to run a number of commands. Now, to do that, I'm going to use a man-in-the-middle attack to automatically inject the hook code for Beef. So I'm going to use a tool called man-in-the-middle-f, and I'm going to do an ARP spoofing attack, and I'm going to give it my network interface, and I'm going to give it the gateway, and I'm going to give it the target IP address, which is the address of the Windows machine. Then I'm going to tell it that I want you to inject a JavaScript URL, and I'm going to give it the location where the hook code is stored. I'm going to hit enter. And that's it running. Now, I know this looks very complicated. You don't know where I got the options from. All of this looks confusing. But again, don't worry about that. We're going to talk about this and go through this step by step, so it'll be very easy for you. Right now, all you need to understand is this program is going to inject the hook code, so the code that allows Beef to hack into that computer. into the browser of the target person so that the code will run without the person even knowing. So I'm going to go to my Windows machine, I'm going to run the web browser, and I'm just going to go to any website, so I'm just going to go to bing.com. Now if we go back to the Kali machine, you'll see that we have the IP address of the target person under the hooked browsers. And if we click on the commands tab, you'll see a large number of categories with commands that you can run on the target computer. Again, we'll talk about that later in future videos. What I'm interested in is a plugin which allows us to show a notification bar on the target computer. And what I'm gonna say in that notification bar is I'm gonna say that there is a new update, click here to install it. So what this is gonna do is it's gonna show the target person that there is a new update, and once they install that new update, I'll hack into their computer. To do that, I'm gonna have to use a backdoor. Now I've already made a backdoor that's not detectable by antivirus programs. I'm not gonna show you how to do that now, but in the course you'll learn how to do that. So right now I'm just gonna say where I stored the backdoor, and I called it update.exe. So that's it, that's all done. I'm gonna click on execute, and that will execute it for me. Now before I go and run the update, I'm going to listen for incoming connections so that I can connect to the target computer once they try to update their computer. So again, I'm gonna explain why we need to do this and how to do this in future lecture. Right now I'm just gonna do it very quickly. And once we do that, if we go on the target machine, you'll see that their Firefox is telling them there is a critical update, and you need to click here to install that update. I'm gonna click it, and you can see that it's downloading an update file for me. I'm gonna save it. Now that's downloaded for me. So if I go to my downloads, just to show you what the file looks like, you can see that it looks like a normal file. It has a nice icon. If we run it, we'll actually get an installer that will update Flash for us. But at the same time, this is going to execute my backdoor at the background. Don't worry about this. I'm going to teach you how to make your Trojans or your evil files look and function just like any other file. So you can have a picture, a PDF, or an installer like I have in here that works like a normal file, but at the same time, when it gets executed, it'll execute your evil code in the background. So now, even though that the target person is happy, they think they're installing an update for their Flash player. If we go back to the Kali machine, you'll see that we managed to get a reverse session from the Windows machine. So I'm going to interact with that computer, and now I'm inside it. So I can do so many things with the target computer. I basically have full control over that computer. And we're going to talk about all the things that you can do in the post-connection section of this course. What I want to do now is I want to show you how to access the webcam of the target computer. So we're going to use a plugin that comes with Meterpreter. So I'm just going to do webcam stream. I'm going to hit enter. And as you can see, I managed to turn on the webcam of the target computer. So this is actually a webcam that's attached to the Windows machine. And right there, you can see me, and I basically hacked into the Windows machine. I can do anything I want on the Windows machine. And I can also turn the webcam. I can inject a keylogger. I basically have full control over that machine. Now, again, this is just an example of one attack that we're going to use. We're going to do so many more attacks like this, and all of them are going to allow us to gain full control over the target system. So don't worry about how to do this attack. Don't worry about the commands. Don't worry about all of that. This is just a teaser, a simple taste of the things that you'll be able to do by the end of the course. Now, as I promised you, this course is going to be highly practical, but I also promised that I will not neglect the theory. Now, what we mean by hacking is being able to gain access to a system that you're not supposed to have access to. So, for example, logging into an email account that you're not supposed to have access to is considered hacking that account. gaining access to a remote computer that you're not supposed to have access to is hacking that computer. Reading information that you're not supposed to be able to read, again, is considered hacking. So you can see that there is a large number of ways to hack into a system, and the word hacking can refer to a number of things, but the main concept is the same. Gaining access or being able to do things that you're not supposed to be able to do is considered hacking. Now, there are three main types of hackers. We have the black hat hackers. These are the bad people that hack systems illegally in order to steal money or to achieve their own illegal goals. The second part of hackers are the white hat hackers. So this is us. These people use the same techniques used by the black hat hackers, and they also hack into systems. But they only hack into systems that they have permission to hack in order to test the security of these systems. And finally, we have the gray hat hackers. These are a mixture of the two. So they'll hack into any system, even if they don't have permission to test the security of the system, but they will never steal money or damage that system, and in most cases they'll go ahead and tell the administrator of that system. But what they do is still illegal because they test the security of systems that they do not own or do not have permission to test. Now, one big question that people always ask is, why hacking? Why teach or learn hacking? Well, hacking is an existing industry. There are lots of job opportunities for ethical hackers, for people like us who would go ahead and test the security of systems to make sure that these systems are secure and not vulnerable to black hat hackers. There is actually a huge demand for ethical hackers these days because of the increased amount of hacking attacks. So we hear on the daily big systems and big companies are getting hacked. Not so long ago, Uber got hacked and information of more than 56 million users were exposed. So companies like Uber, Facebook, and Google, they hire hackers in order to try and hack into their systems and tell them where the weaknesses are so that they can fix it. They also have bug bounty programs where they literally ask all the hackers around the world to go ahead and try to hack into their websites and with their web applications, and if they could, they will pay them a bounty for the bugs that they find. As I mentioned, this course is going to be highly practical. Therefore, you will need a lab, a place where you can practice and experiment with the things that you're going to learn in the course. Not only that, but having a lab is essential for hackers or pen testers, because let's say you discovered a new attack or you want to experiment with a new attack, or you learned something new online and you want to test it, then the perfect place for you to test this and practice hacking is a hacking or a testing lab. Now, to create a lab, you just need a number of computers with different operating systems, and you'll need a number of networks if you're testing network attacks, and if you're testing website attacks, then you will need to install websites on these computers. Or you can do all of this inside your computer, inside one machine, and install everything else as virtual machines. And this is what we're going to do. So let's say you have your computer right here. This is your main computer that you use every day to check your emails or even to watch this course. This computer might be running Windows, OS X, or Linux. It doesn't really matter. It can run any operating system. You can keep all the programs that you love and like, and install a virtualization software such as VirtualBox. A virtualization software allows us to create a number of virtual computers inside your main computer. So we can have 3 or 4 or 5 or 10 computers all installed inside your main operating system, inside your main computer. The really cool thing about this is you will not need a number of computers. You can do everything inside a single computer. So what we're going to do is we're going to have a hacking machine. This is going to be the machine that we will use in order to hack into other machines. We're going to install Kali Linux on it, and we'll talk about what that is later on. And we're going to have two target machines. These are machines that we're going to try to hack into and practice hacking against. One of them is going to be running Windows, and the other one is going to be running an operating system called Metasploitable, and we will talk about that once we get to it. Now, it is very important to understand that you will not lose any functionality when you install an operating system as a virtual machine. You can use that machine exactly as if it's a real physical machine. So the really cool thing about using virtual machines, first of all, you're not going to lose any functionality. Second, all the machines are going to be isolated. So as we go through the course, we're going to be trying to hack into these machines, and we might actually break one of them. But that's fine. It will not affect your host machine. You will be able to easily fix this and go back to a snapshot of when the machine was working without affecting your main computer. The other cool thing is that you'll be able to have a number of different versions of each of these machines, and you'll be able to change the configuration easily, change the network settings, or switch between different states of these machines, and so on. So, by using virtualization, you will not lose any functionality, but you will gain so many cool features. And the main thing to keep in mind is your host machine, your main computer, will never be affected. It's completely isolated. And if we break any of these machines, nothing will happen to your precious computer that you use every day. And this way, you can always use your host machine for daily use, for checking emails, watching the videos, doing whatever you do normally, and then use your virtual machines for hacking and practicing the attacks. And this is what I actually do. So you can see I have my host machine running OS X, and I never use this for hacking. But right here I have VirtualBox, and as you can see I have a number of operating systems installed on it, and I can literally start any of them by selecting the one I want and just click on start. Now don't worry about this, I will show you how to install these virtual machines as we go through the course. But what you need to do right now is download and install VirtualBox, this program. So you can download it from this page. I'm going to include its link in the resources. And like I said, you can install VirtualBox on Windows, OS X, or Linux, so it supports all operating systems. Just pick your operating system from here, download the relevant installer, and install it. Installing it is very, very simple. All you have to do is literally double click the installer, click next, 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 and it'll install it for you. Once you start it, you'll see a program similar to this, but you will not have any virtual machines here, so it will be empty. And I will show you how to install all of these machines as we go through the course. One more thing to do as soon as you install VirtualBox is to download and install the extension pack. This will give you better compatibility, and it'll allow you to use USB devices on the virtual machines. So you'll be able to use a USB mouse, USB keyboard, and USB wireless adapters. Again, downloading and installing the extension pack is very, very simple. There is only one file. It's always the same file for all operating systems. It's the same for Windows, for Linux, for OS X. You just have to click on the download link in here. Once you download that, I already have it downloaded, so I have it right here. And this file will only work if VirtualBox is installed successfully. So first of all, install VirtualBox from these links right here, like I said. Once you download it and install it and can see a window similar to this without these machines right here, we'll see how to install these later. Then download the extension pack from here. You'll have its file similar to this file. and only then you can double click this file and it will automatically open in VirtualBox. As you can see, it's telling me that I want to install the extension pack. It's giving me the version, which is the same version as the version of the VirtualBox that I downloaded. It has to be the same version, otherwise it will not work. I'm going to click on install. We're going to agree to this license. I'm going to put my password. And as you can see, it's telling us that the extension pack is installed successfully. So now we can go ahead and install virtual machines in VirtualBox. Now throughout the course, we're going to be using a number of penetration testing tools. You can go ahead and install each of these tools manually, or you can do what most pen testers do, including myself, and save time and effort and use an operating system designed for hacking. We're going to be using an operating system called Kali Linux, and it's just a flavor of Linux based on Debian, and it comes in with all the programs and the applications that we need to use pre-installed and pre-configured. This means that we can just install this operating system and then start learning our hacking. There are two options to install Kali. You can install it as a virtual machine inside your current operating system, or you can install it as a main machine, as a main operating system. Throughout the course, I'm actually going to be using it as a virtual machine because using it as a virtual machine works exactly the same as installing it as a main machine, because it will be completely isolated from your computer because it's only going to run inside VirtualBox. So if you break it or if you mess things up, it's very easy to fix. It's very easy to go back to other snapshots, other configurations, and also you won't lose any functionality by using it as a virtual machine. That's why I always use it as a virtual machine. And in this lecture, I'm going to cover how to install it as a virtual machine inside VirtualBox. Now I'm going to be doing the steps on a Mac OS X computer, but these steps are exactly the same regardless of what operating system you use. So if you're on Windows or on Linux, you just have to download the VirtualBox version of your computer, and then the steps shown in this lecture are exactly the same after installing VirtualBox. So I'm going to include the download link in the resources of this lecture, and I have it already opened in here. All you have to do is just scroll down. Make sure you click on the Kali Linux VirtualBox images, not on the VMware, and then download the version of Kali that's compatible with your system. So if you have a 64-bit computer, download the 64 bits. If you have the 32 bits, download the 32 bits. Now one click on this will start the download for you. If you're using Internet Explorer or Edge browser, then you're going to have to right-click and save target as. On Chrome and Firefox, you can just click the link. Now this is downloading for me, and I'm going to stop it because I've already downloaded it. So I already have it downloaded in here. And as you can see, you should get a file with a .ova extension. So you have the name followed by .ova in here. So to install this in VirtualBox, all you have to do is literally just double click the file. And as you can see, I get a window which will allow me to import this virtual machine. Now I'm going to keep everything the same for now, and I'm just going to click on import. Now that's it, the virtual machine is ready to be used. Now before I start it, I want to show you how to modify some of its settings. So we're going to click on it. Then we're going to click on the settings in here. Now depending on the host operating system you're using, the layout of VirtualBox might be slightly different, but using it is exactly the same. So make sure you follow the steps that I'm going to do right now, and it should work on all operating systems, whether you use Windows, Linux, or Mac OS X. So the first thing that I'm going to do, I'm going to go to System, and I'm going to modify the amount of RAM it has. Now depending on how much total RAM you have on your computer, you can leave this at 2 if you want, but 1 GB is enough for Kali. I usually leave it at 2 because I have 16 gigs of RAM, but if you have less, 1 GB is enough for it. Also, if you come here on the processors, you'll see that by default I have 2 processors assigned to it. Again, I have 8 CPUs, so 2 is not gonna cause too much pressure on my computer. If you have less, 1 CPU is enough for Kali. Now, we're gonna go to the network settings, and we're gonna set this to use a NAT network. Now, sometimes when you set this to a NAT network, you won't see a network name in here. If you don't, please check out my link in the resources and it'll show you how to create a NAT network. For me, it already has a NAT network, so I'm going to keep it on this one. And what this setting basically does is it's going to create a virtual network where my host machine, which is my Mac OS X computer in here, is going to be the router for this network. And then all the virtual machines are going to be clients connected to this network. So they're going to get internet connection from my host machine, and at the same time, all of my virtual machines will be connected to a virtual network. This is very handy because my virtual machines will be able to communicate with each other. We can use one of them to hack into the other. We can use it to test network attacks and much more. So it'll first allow my virtual machines to have internet connection. It'll also allow them to communicate with each other. And it will do all of this through a virtual network. It will not use any of your wireless adapters or any of your wireless cards. It will create a virtual Ethernet network. So as far as the virtual machine is concerned, they're going to think that they're connected to a network through a wire. Now, if you're on VirtualBox 6 and have a screen with high resolution, you need to go to Display and set the scale factor to 200%, because otherwise the virtual machine screen will be too small. But only do this if you have a screen with a high resolution and if you're using VirtualBox 6. Otherwise, keep this option the way it is. Now, we're done with this. I'm going to click on OK. And we can start this virtual machine like any other virtual machine. We just click on it and we click on Start. Now I'm going to click inside the virtual machine and hit Enter. And we are inside the virtual machine. Now, if you followed everything that I did so far, started Kali and got stuck at a black screen, so if you did not get the screen that I have right now, then don't worry about that. This is a common issue, and I've included a link in the resources of this lecture that shows how to fix this issue. You can access the resources of this lecture or any lecture by clicking on the resources icon on the top left of the player. If you follow all of the steps shown in the link and you're still stuck at this issue, or if you're getting a different issue, then please post this issue in the Q&A section and we'll respond to you within 15 hours and help you to fix this issue. Now it's asking us for the username, and the default username is root, so ROOT. And then it's asking us for the password, and the default password is the reverse of that, which is TOOR. And that's it. Now I'm inside my virtual machine. Now, since we installed this using the ready image, we can just go to View, Full Screen, and we'll be able to go in full screen, and the screen will resize automatically to the size of our screen. Now note in here, you see that I have a network icon appearing in here, and if I click it, you'll see it looks like I'm connected to a wired network. As you can see in here, it says wired connected. So Kali thinks it's connected to a wired network because we set this machine to use a NAT network. So if I open my browser in here, you'll see that I have internet access. So that's it. That shows how to install Kali Linux as a virtual machine. Don't be intimidated by this new operating system. We're going to go through the basics and we're going to use it a lot, and it's actually going to become very easy for you to use. Also, like I said, you won't lose any functionality when you install Kali Linux as a virtual machine. It's actually better to install it as a virtual machine because it's completely isolated from your computer and it will be very easy to fix if things go wrong. Keep in mind, installing this on different hardware and different computers might show you some errors and some issues. So please, if you have any errors, just add them in the discussions and I'll help you resolve them. One more thing, if Kali feels too slow or laggy, then please try giving it a few minutes because usually when you start Kali, it automatically starts checking for updates. This uses quite a bit of resources which would slow down the whole system. Also, it goes without saying, if your computer is not very powerful, then you should close any unused applications before starting Kali to free up some resources. But as you can see and as you'll see throughout the course, I'm using it with 2 gigs of RAM, 2 CPUs, and it's running very smoothly. And like I said, you can even get away with 1 gigabyte of RAM and 1 CPU. Now that we created our virtual machines, it's a really good idea to take snapshots of them. A snapshot allows you to store the state of the current virtual machine. So it allows you to go back in time or go forward to a certain state after you go back. So you can think of it as bookmarks. For example, now we can take snapshots of our fresh installation of the operating systems, and in the future, if we update or configure something or break something, you can literally just go back to the fresh install or go back to factory settings if you want to call it. Then, if you did something there and then you wanted to go back to your updated system, then you can go back to the updated system as well. So you can literally take a snapshot whenever you want to store the state of the machine, and then you can go back and forth between these states. Now, I'll show you how to do that. I have Kali Linux right here, the one that we installed, and it's very easy to create a snapshot for it. All you have to do is just go on the snapshots here and click on the camera icon. Then it's going to ask you to call this snapshot something, so I'm just going to call it fresh install. And I'm just going to give it a description saying it's a fresh snapshot with no updates. It's always a good idea to give a good name and good description so that in the future you can actually remember what these snapshots stand for. So now that I'm done, I'm just going to click on OK. And now you can see that we have the current state. So whatever you do in here, you can update, you can install programs, you can install libraries, and then if you break something or if you ever wanted to go back to the fresh install, you can just come back, click on the fresh install and restore. So let's see now. I'm just going to go back to the details as normal, and then we're going to start our virtual machine. I'll just show you an example now. So let me just create a new directory in here. So let's imagine that you actually updated the system. Now in the future, we're going to talk about updating the system, and I'm going to tell you that when you update, there is a good chance that some libraries, some programs will not be as up to date as the libraries that will be installed, and then these programs might start giving you issues. Now if you had the issues, you can put them in the discussion and I'll help you with them, but some cases I'll tell you that you need to go back or downgrade to the older version without the update. So all you'll have to do is just get back to the fresh installation to your fresh snapshot. So now I've just created a new file just to show you that once you actually go back, everything will go back to the way it was before the changes that you made. So I'm just going to turn off Kali. And now if we go back to the snapshots, you'll see that we have our current state. This state has been changed, so it's a changed state. Now let's say that you updated and the update was successful, so nothing was broken and you are happy with it. So what you should do is you should just come in and click on the camera icon again to create another snapshot. And we're going to call this one updated system. And then you can just put the date if you want to. And then I'm just going to put the description updated with no problems. So I'm going to click OK. And you can see that we have two snapshots. We have the first one, which is our fresh install. And then we updated our system and we have an updated snapshot of an updated system. So now let's say that after you updated and you thought everything is okay, you are using the machine and you have problems, so you wanted to go back to the fresh installation. All you have to do is just click on the fresh install, and you can see that the restart icon right here, just click that. And now it restored me to the fresh installation. So now if I start the Kali machine, you'll see that the new directory that we created will disappear. Now, as you can see, we're back to where we were without the new directory, without anything. So we are actually back to the fresh installation of Kali, to when we actually took the snapshot. So now I'm going to show you another example. So let's say you went back in time and you went back to your fresh installation, and then for some reason you wanted to go back to your updated state to see if you can fix the issue, if I suggested the solution, or if you read the solution online and you want to go back and fix the issue that you had after the update. Or for any other reason, maybe you just wanted to go back to a different state. It wasn't an update state. I'm just giving an example with the update. So if you want to go back to a future state, you can still do that. So all you have to do is just, again, click on the updated, click on the restore. And we don't want to create a new snapshot from the current state because the current state is the updated state. So we're going to restore this, start the machine, and you'll see that we'll be back to the updated state to where we had the new directory created. So we're actually going to go back in the future now. And as you can see, now we have our test directory. So we're back to the state where we updated the system. So again, as you can see, the snapshots can be really useful. They can allow you to store bookmarks or states of the operating system. So you can actually have different configurations and you can switch between them as you want. Okay, now that we have Kali Linux installed, I want to give you a basic overview of this operating system in this lecture so that you're comfortable with it, and we're going to be using it throughout the whole course, so everything is going to become easier for you as we go through the course. Now, the first thing that I want to talk about is the status bar in here. So you can see we have an applications menu in here, and inside it you can see all the applications are categorized. So we have information gathering applications, vulnerability analysis, web application analysis, reverse engineering, and so on. So you can go on each one of these entries and just select any program that you want to run. And the next menu that we have is the places, which shows you the most common places in the file system. So we have home, we have the desktop, we have the documents, downloads, and so on. So you can access the places from here and then you click on home, or you can just click on the files icon in here on the left, and both of these will bring you to the home directory, which is actually the root directory. So it says home in here, but the actual location of this, if I do Control L, you'll see it is /root. So inside this, you can see we have our downloads, music, pictures, similar to the way that you'd have it in Windows and OS X. We also have the time in here, and in here on the right we have more controls. So the first thing that we have in here is the workspaces. So Linux comes with multiple workspaces by default. Basically what this allows us to do is we can have this desktop in here. For example, we can open the places and we can, for example, navigate to downloads and do some work in here. But if we go here to workplaces and go to the second one, you can see that I have an empty desktop that I can do whatever I want. And for example, I can launch Firefox in here. And then again, if I want to go back to the first workspace, all I have to do is click on here, click on number 1, and I'm back in here. And because I've already used up 2 spaces, the system is already creating a third empty space, so I can click on that, and as you can see, I'm in the third space where I can do more stuff. Now you can also navigate between the spaces by pressing Ctrl Alt up or down to go up and down in the spaces. The next part of the status bar is this last part in here, and if you click on it, basically the first thing it'll allow you to do is control the sound, Next, you'll see your connections. So as you can see right now, and as I showed you before, this is showing up as if we're connected to a wired network because I configured this network to use a NAT network. If you have a wireless adapter connected to this computer, you should be able to see it here. If you don't see it, then follow the link in the resources of this lecture to see how to properly connect your wireless adapter or any USB device to a virtual machine. Now, I should note, you can only use external USB adapters in order to access Wi-Fi networks from Kali. You cannot use the built-in Wi-Fi card. But Kali should have internet connection anyway because it is configured to use a NAT network, and as you can see in here, it's telling me my wired is connected. So if I actually go down to Firefox, I'll close this. And if I just go to google.com, you can see it is connected to the internet. So let's go back to where we were. And if we click here, we also have the battery settings, the user settings. You have this button to turn off the machine. This is to lock the machine, and this will show the preferences where you can modify the preferences of the machine. So you have Bluetooth, Wi-Fi, change the background, change the languages, and so on. So you can spend some time getting familiar with this. It's very easy and very intuitive. Same goes to the file manager in here, very intuitive. Double click to go in. You can right click and archive and extract here to uncompress it. You can navigate throughout these files by clicking them, and then you have the trash here, which contains the deleted files. Now we also have the dock in here, which contains the favorite applications, and you can also access all the other applications by clicking on this icon right here, the show applications, and this will show you a menu with the most frequent applications, and then if you click on all, it will show you all the available applications. Okay, now that we had a quick overview of Kali Linux, I want to spend some time talking about the Linux terminal. So you can access the terminal through this application right here. So if we click on that, it will open the terminal window for us. And as you can see, all it is a black screen where you can type commands. Now, the Linux terminal is actually very, very powerful because it can be used to do anything that you can think of, really. A lot of the applications in Linux that have a graphical interface were command prompt programs first, and then people made a graphical interface for it. So a lot of the time, maybe the graphical interface will be buggy or crash, and the terminal program will still work. Also, a lot of the penetration testing tools do not even have a graphical interface. A lot of them can only be used throughout the terminal. Not only that, but in many scenarios, you might only have an SSH or a command prompt access to a machine. So you need to know how to use this command prompt in order to achieve your goals. So throughout the course, we're going to be using the terminal a lot, and that's why I want to spend some time just showing you the basics of it and making sure that you're going to be comfortable using it. Now, the basic idea is you type a command and the result will be displayed for you on screen. So let's have a look on a very, very simple command, which is pwd. Now this command prints the current working directory, hence the name pwd. So if I hit enter, you can see it's printing /root, which means right now I am in the root directory. So basically I am in here. This is the root, it's home. So if I do ls, which is a command to list all the directories and files in the current working directory, we should get all of these directories that we see in here. So if I hit enter, as you can see, I can see all these directories in the current working directory. Now, another very useful command is the cd command. This command allows us to navigate into another directory. So for example, let's say I want to navigate into the downloads. All we have to do is type cd followed by the name of the directory that I want to navigate to. So I'm going to type downloads. Now if I hit enter, I should be inside the downloads now. So if I do pwd to see my current working directory, you'll see that it's saying I'm in root/downloads. So if I do ls here, it should show me all the directories and files inside downloads. So if I do enter, as you can see, I have a directory and a file in here, and these are the exact same files that you'll see if you double click the downloads here. Now, if you want to go back one directory, so similar to pressing the back button in here, all you have to do is do cd, again the command to change the working directory, followed by ... And now if I do pwd, you'll see I'm back in root, and if I do ls, you'll see all the directories and files in root. So that's all good, and there's actually a huge number of commands that you can use. So I'm going to include a link in the resources of this lecture of all the Linux commands that you can use. You don't need to know them by heart. We're actually going to be using a lot of them throughout the course, so you're going to naturally learn them as you go through the course. Now, if you are using a command and you're not sure about how this command works, you can just use the man command to display the manual of this command. For example, we've used the ls command here to list the files and directories in the current working directory. But if I do man followed by ls, this basically means I'm requesting the manual of ls. So I'm asking, how can I use the ls command? So if I hit enter, you'll see I'll get a screen similar to a text file, and basically it's giving me a lot of information on how to use the ls command. So you can see that it's telling us that this command will list the directory contents. You can see the way it works by typing ls, followed by the options, followed by a file if you want to run it on a file. You can see a longer description of the command. And then you can see all the options and the arguments that we can use with this command. Now, in Linux, most of the time, the options will always follow the same syntax. So you either use -letter or -- a word to specify the argument. For example, in here, the -a and -- will ignore entries starting with dot. So if you keep going down in here, you'll see all the options and arguments you can use with the ls command. And we have another example here. We have the -l, which means it's going to use a long listing format, which will display more information about the files in the current working directory. So let's have a look on that. I'm going to press Q to exit this, and then we're going to do ls as usual. And since we read the manual, we know we can do -l to see more information about the files. And if I hit enter now, you can see I'm still getting the same directories, but it's also showing me the permissions, the users, the date created, and so on. So you can use the man command on any command you want, not only on the ls. So you can use it on the pwd, you can use it on the cd, or any other command, and it will show you full description or the manual page of how to use this command. Now, I'm going to clear the screen by typing clear. And the next thing that I want to show you is the --help. So this is something that you can use again in almost all commands and all programs in Linux. So you can just type the program name or the command name followed by --help. As you might think, this will show you a help message telling you what this command is or what this program is, the arguments that it takes, how to use these arguments, and examples at the bottom. Now, another useful thing with the terminal, so I'm going to clear this again, is the arrows. So you can press up to go up to see all the commands that we executed before, and again you can go down to navigate between the commands that you executed previously. You can also use the tab for autocomplete. So again, let's do ls, and you can see all the files, and let's say we want to go into documents. So we can do cd followed by documents you can type documents, or if you're lazy like me, you can just do DOC and press tab, and as you can see, it's automatically completing the rest of the word for me. So this is something that comes very, very handy when you're using the terminal for a long time. Now, what I also want to show you is how to install programs in Kali from the terminal. So first I'm going to clear this. And the first thing that you want to do is update the sources where Kali can search and download programs from. So we're going to do apt-get update. Now apt-get is the name of the application that allows us to download and install programs, and we're saying update because I'm saying that I want you to update the list of all the programs that I can install. So I'm going to hit enter, and you want to make sure that you have internet connection when running this. And as you can see, it's telling me that it's done. And now we can go ahead and start installing applications. So the first program that I want to install is actually a terminal program, so similar to this one, but it allows us to have multiple terminal windows open in the same window. So in order to install a program through the command line, we're going to do apt-get, which is again the name of the program that allows us to install programs on the system. We're going to say that I want to install, and the program that I want to install is called Terminator. So very, very simple. First of all, we're typing the name of the command, which is apt-get. We're saying that I want to install, and the program name that I want to install is called Terminator. So I'm going to hit enter, and this is going to download and install Terminator for me. So you can use the same command to install any program that you want. You just need to replace Terminator with the name of the program that you want to install. Now I've already downloaded and installed this before, so it didn't ask me to confirm. But if you're running this for the first time, it might ask you to confirm whether or not you actually want to install this program. So all you'd have to do is press Y from the keyboard and hit enter. Now, as you can see, it's done. So if I go to my all applications in here and just type Terminator, you can see that I have it here. So I'm actually going to drag it and put it in my dock so I can access it easily in the future. So now I can just click it in here, and that will open Terminator for me. Now this is another application that allows me to run commands, so it's exactly the same as this. So again, I can do ls and pwd. The only difference is with this one, I can actually right click and click on split horizontally, for example, and this will split the same screen into two screens where I can run commands at the same time. So I can have some commands in here and I can run commands in here. And then I can even split this more if I want, again vertically or horizontally. And as you can see, I can have as many terminal windows as I want, and this will be very helpful in the future when we'll be running a number of programs and a number of commands at the same time. The first penetration testing section in this course is going to be the network hacking section. The reason why I chose to start with this, because everything, if you think of it, is connected to a network. So whether your target is a personal computer, whether it's a server, whether it's a company, or even if it's just a website, all of these systems are actually connected to a network. Literally, when you just connect to the internet, you're connecting to a network because the internet is just a really, really big network. So it is very important that you understand how networks work and how devices communicate with each other before we actually move into the next sections. So this section is actually going to be divided into three subsections. In the first subsection, we're going to talk about all of the attacks that you can do before connecting to a network. So you literally just have a computer with a network interface, possibly a Wi-Fi adapter, and we're going to see what can you do now before even connecting to anything. In the second subsection, I'm going to show you how to crack Wi-Fi keys and gain access to Wi-Fi networks, whether they use WEP, WPA, or WPA2. Once you have the access, you can move to the third section, which will apply for both Wi-Fi and wired networks. All of the attacks that you will learn in the third subsection apply whenever you are able to connect to the network, once you're able to gain access to the network. And here is where the real fun starts, because you're going to learn a number of powerful attacks that will allow you to intercept the connections in the network and capture everything sent in it, including usernames, passwords, URLs, chat messages, and so on. Not only that, but you'll also be able to modify data as it's being sent in the air. So you'll be able to control requests, serve people fake updates, inject evil code into the pages that they load, and so many other cool things. So everything in the third section will apply for both Wi-Fi and wired networks. Now, before we start talking about network hacking, you need to have a basic understanding on how networks work. Now, we all know that a network usually contains a number of clients connected to each other, and clients usually connect to a network in order to share data or share a resource. A really good example of a resource that we all have connected to networks in order to access is the internet. So we connect to Wi-Fi networks and even wired networks all the time just to access the internet. Now, all networks, whether it's Wi-Fi or wired, work on the same principle. They have a device that is considered a server. Now, in many cases, for example, in your home network, this server is your router. This is also referred to as an access point. Now, this router or server or access point is the only device that has access to the resource. So none of these clients have direct access to the resource, even after connecting to the network. The only way they can access the resource is through the access point. So, let's say for example you're client number 1 and you connected to your home network over Wi-Fi or over Ethernet over a cable, and then you opened your browser and you typed google.com. What happens is your computer will send a request to the access point asking for google.com. The access point has access to the resource, which is the internet in this example, so it's going to go and look for google.com. It will receive google.com and it will forward that response to your computer, and as a result, you will see the website loading on your browser. So, if you actually go to your router at home and look at it, you'll see at the back it's connected through a cable to the wall, and this is how it's getting its internet access. Therefore, it is the only device in your network that has direct access to the resource, and none of your computers, none of the computers connected to the network can access the resource or can access the internet without the router, without the access point. So the only way for all of the connected clients to access the resource is to go through the router. Now, the data is transferred between the clients and the access point as packets. So you can think of all of these arrows as a series of packets being transmitted between the client and the router as requests and responses. Now, in Wi-Fi networks, these packets are transmitted in the air. Therefore, if you have a wireless card and you're within range, you'll be able to capture all of these requests and responses. So basically, you'll be able to see anything that any computer connected to the same network as you does on the internet. because they will have to send all of this data to the access point, and because they're sending this data in the air because you're in a Wi-Fi network, you'll basically be able to capture these requests and responses, and you'll be able to see the URLs they visit, the usernames, the passwords they enter, the chat messages. Anything they do on the internet will be sent as packets, and therefore you'll be able to capture it and analyze it. We'll talk more about that and more about how networks work as we go through the course. But this is enough to get you going through the next few lectures so that you can sniff data, analyze it, and start launching some cool pre-connection attacks. In this lecture, I'm going to show you how to connect a USB device to a virtual machine. As an example, I'm going to be connecting a wireless adapter to my Kali machine. But the same method can be used to connect any USB device. Now, as mentioned in the course requirements, you need a wireless adapter for the cracking section of this course. So these are listed in the course requirements, and I'm going to list them in the resources of this lecture, and you can connect them to Kali like I'm going to show you right now. So I already have VirtualBox open, and you just want to click the machine that you want to connect the adapter to. We're going to go to its settings. We're going to go to ports. We're going to go to USB and make sure that USB is enabled. And you want to pick the USB option that is used by your adapter. So it's either USB 1, 2, or 3. And for the adapter that I have, it uses USB 2. Then you want to come here to the plus sign and click on it. Now you'll see that I have a number of devices that I can attach to the Kali machine. Now I still haven't connected the adapter. So first of all, I'm just going to have a look on the available devices. Then I'm going to connect the adapter. And I'm going to list the devices again. I did that because we're assuming that I don't know the name of my adapter, because the name that you'll see here is the name of the chipset that's used inside the adapter. So it's not the brand name that you see on the adapter itself. So when I click on it now, you'll see that I have a new entry called Atheros, and this is actually my wireless adapter. It's an Alpha AWS 036NHA. So I'm going to click on it. That's it added here. I'm going to click on OK. And that's the adapter added to Kali. Now, before starting my virtual machine, I'm going to physically disconnect my wireless adapter. And then I'm going to connect the adapter once Kali fully loads. Now I'm going to start it. So I'm going to put my username, which is root, and my password, which is TOOR. Okay, now Kali is fully loaded. I'm going to go and physically connect my wireless adapter. And like I said, I usually do this just to avoid any conflicts. Now, once the adapter is connected, you want to make sure that it's attached to Kali. And to do that, we're going to go to the devices menu. So we're going to go all the way to the top. We're going to go to devices. We're going to go on USB. And we're going to make sure that this adapter right here is checked. Now, sometimes it might not be checked for you, so click on it to check it. For me, it's already checked, so I'm not going to click it. And to confirm that the adapter is connected, we can just go on terminal right here and type ifconfig. This command lists all the interfaces that's connected to the machine. And as you can see now, it's showing an adapter called LAN 0, which is the wireless adapter. So if you have this in here, that means your adapter is connected. If you don't, then ask in the discussions and I'll help you through this. Some adapters are not compatible with Kali, so that could be the issue, or the issue could be something else. Also, now if we go here on the top right, you'll see that I have a Wi-Fi option, which I can use to connect to Wi-Fi networks. Now, we don't need to do this because I showed you how to set up a NAT network, and Kali already has internet access through this NAT network. So we only need the wireless adapter to hack into other networks to crack their passwords. When it comes to networking, you probably heard of the term MAC address a lot. So in this lecture, I'm going to cover what do we mean by MAC address, what it's used for, and how to change it. MAC address stands for Media Access Control. It's a permanent, physical, and unique address assigned to network interfaces by the device manufacturer. So whether you have a wireless card or a wired or Ethernet card, each one of these network cards come with a specific address that is unique to this card. So there is no two devices in the world that would have the same MAC address, and this address will always be the same to this specific device. Even if you unplug it from your computer, connect it to another computer, then this network device will always have the same address. So you might already know that the IP address is used in the internet to identify computers and communicate between devices on the internet. The MAC address is used within the network to identify devices and transfer data between devices. So each piece of data or packet that is sent within the network contains a source MAC and a destination MAC. Therefore, this packet would flow from the source MAC to the destination MAC. So, because this is a physical unique address to each interface, to each network device, and because it is used to identify devices, then changing it will make you anonymous on the network. Not only that, but the MAC address is often used by filters to prevent or allow devices to connect to networks and do specific tasks on the network. So being able to change your MAC address to another device's MAC address will allow you to impersonate this device and allow you to do things that you might not be able to do. So you'd be able to bypass filters or connect to networks that only specific devices with specific MAC addresses can connect to, and you will also be able to hide your identity. Now, changing the MAC address is very simple. So let me show you how to do that. First of all, I'm going to use the ifconfig command to list all the network interfaces available on my Kali machine. What I mean by network interface is any device that allows us to connect to a network. So an example is a Wi-Fi card or an Ethernet card and so on. So you can see, first of all, we have ETH0, and this is a virtual interface created by VirtualBox when we set Kali to use a NAT network. So you can see the interface name is ETH0. You can see it has an IP address because, like I said, it's connected to a network. So if we go here, we can see it's saying wired connected. So this is the interface that represents the wired network that Kali is connected to, which is actually a virtual NAT network. You can also see the net mask, the broadcast, and a really important piece of information, which is the other. This is the MAC address of this virtual interface. Now you can see similar information for my other two interfaces, the LO and the LAN 0. The only thing is, you can see for both of these interfaces, we do not have an IP address. And the main reason for that is because none of these interfaces is connected to a network. Now LO is a default interface created by Linux, and LAN 0 is my real wireless adapter, so I can use it to connect to Wi-Fi networks. But if I go on the network in here, you'll see Wi-Fi is not connected because I actually didn't connect to any network, and that's why it does not have an IP address. Now this doesn't matter because what we want to do is to just change the MAC address, which again is shown here under the other part. So similar to what you're seeing here for ETH0. Now, in order to change any of the values that you see in here, you have to first disable the interface. So in this example, we want to change the MAC address. So that is represented by the other, and the value is right here. So in order to disable an interface, we're going to do ifconfig, followed by the interface name, which is LAN0 in my example, followed by down to disable it. Now, if I hit enter, you'll see the command runs with no errors, so it means that it got executed properly. And the next thing that we need to do is to change the option that we want to change. And in this example, we want to change the other, which is the MAC address. So first we're going to type ifconfig. We're going to type the interface that we want to change one of its options. Then we're going to type the option that we want to change. And what we want to change is the hardware address. So we're going to do HW other. Then we're going to give it the address that we want to change the MAC address to. So for example, I'm going to use 001122334455. Very simple command. We're doing ifconfig LAN0 to select the interface that we want to change its option. We want to set the hardware address, and we want to set this address to this specific address. So you can use any address that you want following the same format shown here. Just make sure your address starts with 00. So I'm going to hit enter, and again we don't see any error messages, so it means the command got executed properly. And finally, we just need to enable the interface because we disabled it by doing ifconfig LAN0 down. So we just need to do ifconfig LAN0 up to enable it. Now the interface is enabled, and if we do ifconfig again and look at the other part in here, you can see that it is changed to the MAC address that we specified. Now this is done and your MAC address is changed. Now you can go ahead and start using the interface, and it will appear to have this MAC address instead of its original MAC address. And like I said, this can be useful in so many scenarios. Now keep in mind, the MAC address will revert back to the original one once you restart the computer, because we're only changing the MAC address in memory. We're not really changing the physical MAC address. But if your MAC address is resetting to the original one without restarting, then something is going wrong, and it's probably happening because your network manager is resetting the MAC address. Not everybody will face this issue, so I'm not going to cover it in this lecture. But if you face this issue, if your MAC address goes back to the original one without restarting the computer, then check out the YouTube video in the resources of this lecture. It will show you how to fix this issue. From the previous lectures, we learned the basics of how networks work. We learned that devices on the same network communicate with each other using packets. So regardless of what you do on the network, whether you're watching a video, whether you're logging into a website, sending chat messages, sending emails, regardless of what you're doing, all the data is sent as packets. Now in the network, devices ensure that these packets go in the right direction using the MAC address. So each packet has a source MAC and a destination MAC, and it flows from the source to the destination. So in this example, we have the client, it has this MAC, we have the access point, which has this MAC. And as an example, if this client wanted to send a packet to the router, it will set the destination MAC to the router's MAC address. Therefore, by default, each device only receives data that has the destination MAC as its own MAC address. But if you remember, I said in wireless networks, if you're within range, then you'll be able to capture all of this communication because these packets are literally sent in the air. So we can just capture them even if they do not have our MAC address as the destination MAC. To do this, we need to change the mode of operation of our wireless interface so that it operates in monitor mode. So let me show you what I mean. If I go to my computer here and run iwconfig this time, so we see an ifconfig which lists all the interfaces. We can use iwconfig to see the wireless interfaces only. And you can see we have LAN 0 right here, which is my external wireless adapter. And you can see the mode of this adapter is set to managed. What this means is basically this is the default mode of all wireless devices, and what it means is this device will only capture packets that has the destination MAC as the MAC address of this device. So basically it will only capture devices that are directed to my Kali machine. But this is not what we want. What we want is to be able to capture all the packets that are within our range, even if they are sent to the router and even if they are set to another device. So to do this, we need to set the mode to monitor mode instead of managed mode. So as usual, before you can change the options of your interface, you have to disable it. And previously we've seen we can do that by doing ifconfig, the device name, which is LAN 0 in my case, down. Then we can enable monitor mode. But before we do that, I'm actually going to run a command to kill any process that could interfere with using my interface in monitor mode. So the command that I'm going to run right now is not mandatory, but running it will actually give you better results when you come to running the attacks that you will learn as we go in the course. So this command is going to be airmon-ng check kill. Now you'll notice when you run this command, it will actually kill the network manager that usually runs in here. So you'll completely lose your internet connection. But this is no problem because we will only need to be in monitor mode when we are running pre-connection attacks, so attacks that do not require us to connect to any network. So we actually do not need internet connection to run any of the attacks that require monitor mode. Now we're going to enable monitor mode, so we're going to do iwconfig followed by the interface name that we want to enable monitor mode on, which is LAN 0. We're going to say that I want to change the mode and I want to change that to monitor. So very simple command. We're using iwconfig to change the mode. We're given the name of the interface that we want to change its mode. We're saying I want to change the mode and I want to set it to monitor mode. Now if I hit enter, you'll see the command will run with no errors, which means the command got executed properly. And finally, we'll need to enable the interface, again similar to what we did when we changed the MAC address. So we just have to do ifconfig LAN 0 up. That's done. Now if I run iwconfig again, you will see that the mode is set to monitor now. So basically this interface now can be used to capture any packet that is within our range, not only the packets that are directed to this computer. That's why in the future you'll see how we can use it to sniff packets, to analyze them, and even break into networks. So in the future, if I say use your interface in monitor mode, this is what I mean. You'll basically have to enable monitor mode as shown in here. Now, I've also included a YouTube video in the resources of this lecture to show an alternative method to enable monitor mode. Just in case you got errors with this method or you tried to follow something that I do in the next lectures and it didn't work, then you can come back and try the alternative method. But if this worked and if monitor mode is enabled successfully, then you don't need to watch that video, you can just continue with the course. One more thing to keep in mind, not all wireless adapters support monitor mode. So for this to work, you need to make sure that your actual adapter supports monitor mode. There are a number of adapters that support that, and I've included another video, again in the resources, of me talking about wireless adapters, how to pick the best one, and which ones that I recommend and use when I'm testing the security of networks. Now that we have enabled monitor mode on our wireless interface, we are able to capture all the Wi-Fi packets sent within our range. Even if the packet is not directed to our computer, even if we're not connected to the target network, and even without knowing the key or the password to the target network. So all we need right now is a program that can capture these packets for us. The program that we're going to use is called AeroDump-NG. It's part of the AirCrack-NG suite, and it's a packet sniffer, so it's basically a program designed to capture packets while you're in monitor mode. So it'll allow us to see all the wireless networks around us and show us detailed information about its MAC address, its channel, its encryption, the clients connected to this network, and so on. So let me show you how we're going to use it. First of all, you need to enable monitor mode on your wireless adapter as shown in the previous lectures. So if I go to my Kali machine and run iwconfig to list all the wireless devices on this computer, you'll see that I have an interface called Mon0, and this interface is in monitor mode. Now, depending on the way that you enabled monitor mode, this can be called LAN 0, it can be called LAN 0 Mon, it doesn't really matter. You just want to make sure you enable monitor mode using one of the methods shown before, and then use the name of the adapter that is in monitor mode when you run AeroDump-NG. Now to run AeroDump-NG, we're just going to type the name of the program, which is AeroDump-NG, followed by the name of my wireless adapter in monitor mode, which is Mon0, as you can see in here. So the command is very simple. We're typing the program name, which is AeroDump-NG, followed by the name of my interface in monitor mode. If I hit enter, you'll see it'll start working, discovering all the wireless networks around me and displaying useful information about them. This program will continue working unless you quit it, and to quit this program, you have to press Ctrl-C from your keyboard. You can actually use Ctrl-C to quit any running program in your terminal. Now that we stopped the program, let's analyze the output so we understand what it's showing us. So first of all, if we look at this column, the ESSID column, it should be a little bit familiar to you. And basically, this shows us the names of the wireless networks around us. So if I just go to my Mac machine and look for wireless networks, you'll see the same names that we see in here displayed under the ESSID. Now all of the other columns show us more information about the network name that you see in here, and this information will actually be very useful to us as we go through the course. The first column, the BSSID, shows us the MAC address of the target network. Next, we have the PWR, so this is the signal strength or the power of the network. Now, the higher the number, the better signal we have. So for example, the network with the best signal right here is this one. Next, we have the beacons. These are frames sent by the network in order to broadcast its existence. So every network, even if it's set to be hidden, always sends these type of frames, basically broadcasting its existence and telling all the wireless devices around it that I exist, I have this BSSID, I work on this channel, I use this encryption, and my name is this. Next, we have the number of data packets or data frames, and these are the useful packets that we'll talk about later on once we get to the cracking section. This column represents the number of data packets that we collected in the past 10 seconds. Next, we have the channel, which is the channel that the network works on. So for example, this network right here, the test AP, works on channel 6. This network works on channel 1, and so on. Next, we have the maximum speed supported by the network. The encryption is a very important column, and it shows us the encryption used by the network. So we can see that the test AP network is using WPA. We can see we have a network that uses web. We can see this network right here is an open network, so it doesn't use encryption. We don't even need a password to connect to it. And we can see we have a WPA2 network right here. Cipher is the cipher used in the network. So we can see here we have CCMP, we have web, and we have CCMP again here. Auth is the authentication used on that network. And in here we can see it's PSK, pre-shared key, and MGT for this network. Now don't worry about the INC, the cipher, and the auth. We will talk about breaking into all these networks into web, WPA, and WPA2 in the gaining access section. And finally, you can see we have the ESSID section, which shows the name of the network. So this is what you see when you look for networks in your network manager. So that's it for this lecture. I just wanted to give you a quick look on how to discover all the networks around us using AeroDumpNG. Don't worry about AeroDumpNG too much now. We're going to be using it a lot in the next lectures, and you'll get very comfortable with using it as we go through the course. In this lecture, I'd like to talk about Wi-Fi bands. The band of a network defines what frequency it can use to broadcast the signal. This means it also defines the frequency that the clients or the computers need to be able to support and use in order to be able to connect to this network. The two main frequencies used in Wi-Fi networks are 2.4 and 5 GHz. Now, previously, when we used AeroDumpNG, we were only sniffing on the 2.4 GHz frequency. You can see, first of all, my wireless adapter is in monitor mode, Mon0 in here. So if I just do AeroDumpNG Mon0, you'll see that I can get the wireless networks around me. But you might have noticed that you won't actually see all the networks around you when you run AeroDumpNG. I'm going to Control-C this, and if I go here to my normal host machine, and it actually has a built-in wireless adapter, so it's not as strong as my alpha adapter. But if I look for networks, you'll see I actually have much more networks in here. And mainly, I have networks ending here in the name by 5G. Now, the network doesn't have to necessarily end in 5G, but here in Ireland, if a network broadcasts over 5 GHz, the service provider adds 5G to the network name. But we also have other networks broadcasting over 5G that don't end in 5G. But basically the main point that I want to talk about is I'm not able to see all the networks around me in here in AeroDumpNG. And the reason for this is because AeroDumpNG is only sniffing on 2.4 GHz frequency. So if you do this and you don't see all the networks around you, or if you're sniffing on your own network, but you don't see all the clients in your network, it's possible that your router is broadcasting over two bands, over 2.4 and 5 GHz. And if you're not seeing the router at all, if you're not seeing the network at all, like what's happening here for me, then the router is probably just broadcasting over 5 GHz. Now, this doesn't mean that your wireless adapter is not good. It just literally means that this adapter is not able to see 5 GHz frequency. It's just outside of its limit, outside of its reach. The main problem with 5 GHz is that there are a lot of wireless adapters that can see it and can communicate with it, but not many of them support monitor mode and packet injection. So you might see me and other people recommending wireless adapters like Alpha AWUS 036NHA. This is my most favorite wireless adapter. I use it all the time, even now. But the problem with that adapter is it doesn't pick up 5 GHz frequency. So it doesn't mean that that adapter is bad, it just means that it can't see 5 GHz frequency. Like I said, there aren't many wireless adapters that support 5 GHz, but I have an adapter here. It's Alpha AWUS 036ACH, and this adapter supports both 2.4 GHz and 5 GHz frequencies. It's not as good as the Alpha, but it does the job. Now, if you want more information about wireless adapters, check out the link in the resources. I'm not going to talk a lot about what wireless adapters do, but in this lecture, I want to show you how to sniff and discover 5 GHz frequency networks, and then so that you can use all the attacks that you've learned in my other lecture and in my previous videos with 5 GHz networks. So, the adapter that I'm using right now supports 5 GHz, but as you can see, I still can't pick up these networks. That's because I need to specifically tell AeroDump-NG that I want you to listen on 5 GHz frequencies and 5 GHz channels. To do that, all we have to do is just do AeroDump-NG, like we always do. And then we're going to use a new argument that we haven't seen before, and this argument is called band. And we're going to tell it that I want you to sniff on band A, and that's the band that supports 5 GHz frequency. And then I'm just going to give it the name of my wireless adapter in monitor mode, which is Mon0. So the command is very simple. It's very similar to what we've used before, and all we have to do is just type in AeroDump-NG followed by the band, and the band that we want to use is A, and we're following that with our wireless interface. So I'm gonna hit enter. And as you can see, as soon as we hit this, I'm actually just gonna do Control-C now because you can see the results. You can see that we got much more networks right now, and we have the 5 GHz network. So we have this network and this network that we weren't able to see. We have the Jameson Whiskey network as well, and basically we're able to capture all the networks that use the 5 GHz frequency. Now what you can also do, let me clear the screen. You can specify multiple bands using the band argument. So again, using the same command, instead of just saying band A, we can do band ABG. And what this will do is it'll tell AeroDump-NG to capture data on both 2.4 and 5 GHz frequencies at the same time. So let me show you. So as you can see right here, we're capturing some 2.4 GHz networks, and we're capturing 5 GHz networks as well at the same time, and we'll also be able to discover clients connecting to both bands. The only problem with using AeroDump like this is, first of all, you need a powerful wireless adapter to do this. Also, it'll be slightly slower than only sniffing on one band, because when you're sniffing on two bands, you have a lot of channels that AeroDump-NG has to hop on all of them and discover clients and networks broadcasting on these channels. So, if you want quicker results, then you're better off just specifying the band A when you want to sniff on 5 GHz frequencies, and just not specify the band when sniffing on 2.4. But as you can see, you can just run the command like so with band ABG, and this way you'll be able to capture data sent over 2.4 and 5 GHz frequencies. Also keep in mind, in order to sniff data on 5 GHz frequency, like I said, your wireless adapter needs to be able to support this band. So simply adding the band argument will not work unless your wireless adapter can support and can sniff data on this band. One more thing that I want to note, I've actually said this before. If you run AeroDumpNG against a network and you see some devices missing, then there is a high chance that these devices are connected over 5 GHz. So again, use the band A and then you should be able to see these devices. In the last lecture, we've seen how to use AeroDumpNG to list all the networks around us and display useful information about them. Usually, we do this in order to see our target network, see the signal strength, see how far we are from it, and then start targeting this target network. Now, in this example, I'm going to assume that my target network is this one right here. This is actually the network that my host machine is connected to. And now that I have my target network and I have some basic information about it, let's see how we can run AeroDumpNG against this network only, not against all networks. And this way we'll be able to gather more information about it. So to do this, first of all, I'm going to have to write the name of my program, which is AeroDumpNG. Then I'm going to specify a specific BSS ID or a specific MAC address for AeroDumpNG to sniff data from. So my target network has a BSS ID of this. We can see it here under the BSS ID. So I'm going to copy it. And then I'm going to do --BSS ID. And I'm going to give it the BSS ID that I just copied. Next, I'm going to specify a channel for AeroDumpNG to sniff on. Again, if we look under the channel column in here, we can see my target network is on channel 2. So I'm going to do --channel 2. So now we're telling AeroDumpNG that I want you to sniff data on channel 2 and only from a network that has this BSS ID. I'm also going to tell AeroDumpNG that I want you to store all the data that you're gonna gather for me in a file. So I'm gonna say --write, and then I'm gonna type a file name, and let's call this test. And at the end, as usual, I need to give it the name of my wireless adapter in monitor mode, which is Mon0 in my case. So, very simple command. Let's go over it one more time. We're doing AeroDumpNG, that's the name of the program that I want to use. I'm telling it that I only want you to sniff data from a specific BSS ID. Then I'm giving it the BSS ID of my target. Then I'm telling it I want you to only sniff data from a specific channel, and I'm giving it the channel that I wanted to sniff data from. Again, we can get it from here, it's number 2. Finally, I'm telling it that I want you to write all the data that you're gonna capture in a file that we're gonna call it test. And then I'm giving it my wireless adapter in monitor mode, which is Mon0. Now I'm gonna hit enter. And as you can see, unlike the last time, AeroDumpNG is only showing me one network in here. This is the network that I wanted it to sniff data on. And we can also see we have a completely new section right now. So when I ran AeroDumpNG in the previous lecture, you seen I only had the networks in here and I had nothing here at the bottom. But now you can see we have more entries in here at the second section of AeroDumpNG. And basically anything that you see here in the second section, these are the clients or the devices connected to this network. So right now we can see this network has 3 devices connected to it, and you can see the MAC addresses of these devices under the station. So you can see all of these devices are connected to the same network. So the BSS ID is still the same. This is the MAC address of the network. And under the station, we have the different clients or different devices connected to this network. We can also see the power. So this is the signal strength of each of these devices. We can see the speed, we can see the amount of data lost, we can see the amount of frames or packets that we have captured, and we can see if any of these devices are still probing for networks. So sometimes when you run AeroDump-ng against all networks, you'd still see this section, and you'd see that some devices are not connected and they're literally trying or looking for networks. So you'd see the name of the networks that they're looking for under the probe. Now, if I hit Control-C, AeroDump-ng will quit, it'll stop working, but I should have new files in my current working directory that contain the data that we just captured. Because remember, when we ran the command, we used the right option in here to store the data in a file called test. So if I just do ls to list all the files in my current working directory, you can see I have 4 files. All of them start with test, but they all have different extensions. So we have a CSV, we have a netXML, we have a CAP, and we have a Kismet CSV. Now also notice that AeroDump-ng automatically appended -01 to each of these files. So in the future, when you go and try to use the capture file, make sure you append -01 to the file name that you specify in the command. Now, the main file that we're going to be using is the cap file. Again, this file contains the data that we captured during the period that AeroDump-ng was working on in here. And basically, this file should contain everything that was sent to and from my target network. So it should contain URLs, chat messages, usernames, passwords, or anything that any of these devices did on the internet. Because anything that they have to do will have to be sent to the router, as we've seen before. The only problem is, if you look at the encryption in here, you can see that my target network uses WPA2 encryption. So all of the data sent between the router and the clients is encrypted. So let me show you what I mean. I'm going to use a tool called Wireshark to analyze the data. And don't worry about how to use Wireshark. We will talk about it in details later on. Right now, I just want to make sure that you understand the idea that now we're able to capture all these packets. The only problem is these packets are encrypted. So I'm going to do Wireshark to run Wireshark. And then I'm going to open my capture file. So I'm going to go to File, Open, and it's already in my root directory. So I'm just going to scroll down and select my test1 cap. I'm going to open it, and I'll just put this in full screen. And as you can see, if we click on any of these packets, you can see we really have no useful data. You can see everything looks like gibberish, and we can't read anything, even though these packets might contain usernames, passwords, or URLs. The only useful thing that we can see here is the device manufacturer. So we know one of the devices connected to the network that has this specific MAC address. So it's the one that ends with E8. And if we go up, we can see that it's this specific device. We know now it is an Apple device. So it could be an Apple computer, it could be an iPhone or an iPad. And this is actually my MacBook computer that is the host machine. Again, we can see we also have a device that's using a Huawei chipset. So this can be a phone, or it could be the router. And if you look at the MAC address here and compare it to the MAC addresses that we have here, you can see that this is actually under the BSSID. So this is the MAC address of the router. So now we know that the brand of my router is Huawei. So we can gather more information by opening this file in Wireshark, and we can kind of guess what computers are there and what operating systems they use. But this is not detailed enough, and the main problem with this is the fact that the network is using encryption. Now in the next section, we're going to be talking about how to break this encryption, and once we do, you'll see how we can see the passwords, the usernames in plain text, and you'll also see how we can map all of the computers on the same network, gather detailed information about them, hack into them, and do some really cool stuff. Now you should guess by everything that I said so far, if this network was an open network, if it was a network that does not use any passwords, then you would have been able to actually see all the URLs and everything that they do in here. But again, if you can't connect to the network without a password, then you'll automatically be at the post connection section. And in that section, like I said, we're gonna talk about some really cool attacks that you can do once you have the password or once you can connect to the network. So don't worry about Wireshark for now. I just wanted to make sure that you understand why encryption is useful and why it's used and why we can't see much now because we don't know the key. We will talk about Wireshark and all of that later on in the next section. Now, before leaving this section and moving to the gaining access section, where I'm going to teach you how to break the different encryptions and gain access to networks, I want to spend one more lecture talking about a really useful attack that still falls under the pre-connection attacks under this section. The attack that I want to talk about is the deauthentication attack. This attack allows us to disconnect any device from any network before connecting to any of these networks and without the need to know the password for the network. To do this, we're going to pretend to be the client that we want to disconnect by changing our MAC address to the MAC address of that client and tell the router that I want to disconnect from you. Then we're going to pretend to be the router, again by changing our MAC address to the router's MAC address, and tell the client that you requested to be disconnected, so I'm going to disconnect you. This will allow us to successfully disconnect or deauthenticate any client from any network. Now we're actually not going to do this manually. We're going to use a tool called AirPlay-NG to do that. From the previous lecture, we know that this MAC address right here belongs to an Apple computer, and like I said, this Apple computer is actually my computer right here. And as you can see, this host machine is connected to this network right here, which is the same as the one that you see in here. And it actually has internet access. So if I just look for test, you'll see that I'm connected and I can look for things. I can use Google. So I have a proper working internet connection. Now, we're going to come back here and we're going to use a tool called AirPlay-NG to launch the deauthentication attack and disconnect this Mac computer from the internet. So we're going to type the name of the program, which is AirPlay-NG. We're going to tell it that I want to run a deauthentication attack. Then I'm going to give it the number of deauthentication packets that I want to send. So I'm going to give it a really large number so that it keeps sending these packets to both the router and the target device. Therefore, I'll disconnect my target device for a very long period of time. And the only way to get it back to connect is to hit Ctrl+C and quit AirPlay-NG. Next, I'm going to give AirPlay-NG the MAC address of my target network. So I'm going to do -A and give it the MAC address, which I'm going to copy from here. Then I'm going to use -C to give it the MAC address of the client that I want to disconnect. And the client that I want to disconnect is this client right here, which is the Apple computer, like we said. So I'm going to copy it and paste it here. And finally, I'm going to give it the name of my wireless adapter in monitor mode, and in my case, it's called Mon0. So a very simple command. We're typing AirPlay-NG. This is the name of the program that we're going to use. We're doing --deauth to tell AirPlay-NG that I want to run a deauthentication attack. I'm giving it a really large number of packets so that it keeps sending the deauthentication packets to both the router and the client and keep the client disconnected. I'm using -A to specify the MAC address of the target router or the target access point. Then I'm using -C to specify the MAC address of the client. Finally, I'm giving it Mon0, which is the name of my wireless adapter in monitor mode. Now you can run this command like this, and in most cases it would work. But in very rare cases, this command will fail unless aerodump-ng is running against the target network. So what I'm going to do now is I'm going to go back to my first terminal in here, and I'm going to run aerodump-ng using the command that we've seen before. And I don't want to write anything to a file, so I'm going to remove the write argument. So I'm just doing a normal aerodump-ng command. I'm literally just giving it the BSS ID of my target network, and I'm giving it the target channel. And then I'm just going to hit enter. We've seen how to do this. We spent a full lecture on it. That's why I did it really quick. And then I'm going to go back to the command that we wrote so far, and I'm going to hit enter. Now, as you can see, airplay-ng, it's telling me that it's sending the deauthentication packets. And if we go back here and look up, you can see that I actually lost my connection and I'm trying to connect back. So obviously, if I try to look for anything, so let's say test2, you'll see I'll get stuck and nothing will load for me. So the only way for me to connect back is if I go back here, if I quit this by doing Ctrl+C, quit this again, and now my machine should be able to connect back and restore its connection. This is actually very handy in so many ways. It's very useful in social engineering cases where you could disconnect clients from the target network and then call the user and pretend to be a person from the IT department and ask them to install a virus or a backdoor, telling them that this would fix their issue. You could also create another fake access point and get them to connect to the fake access point and then start spying on them from that access point. And we'll see how to do that later on in the course. And you can also use this to capture the handshake, which is what happened in here actually. And this is vital when it comes to WPA cracking. And we'll talk about this once we get to the WPA cracking section. So, like I said, this is a small attack that can be used as a plugin to other attacks or to make other attacks possible. Everything we've done so far can be done without the need to connect to the target network. Now, once we connect to the network, we can do so many cool things. We'll be able to gather so much more info. We'll be able to intercept the connections and see everything that the people send, whether it's usernames, passwords, URLs, or anything really. We'll also be able to modify the data, and you'll see all of this in the next section of this course. Now, if your target does not use encryption, then you can just connect to it. If your target is a wired network, then you can just use a cable and connect to it and move to the next section. The only problem is if your target is using encryption. So, in this section, I'm going to show you how to break that encryption and gain access to Wi-Fi networks, whether they use WEP, WPA, or WPA2. Once we get the key, we'll be able to connect to the network and you'll be able to do all of the things that you'll learn in the next section, in the post-connection section. The first encryption that we'll learn how to break is called WEP, or Wired Equivalent Privacy. This is an old encryption that can be easily broken. The reason why I'm still covering it in this course is, first of all, because, like I said, it's very simple, so it's a good starting point. Also, it's still used sometimes in some networks. Therefore, you can't really call yourself a hacker, and then if you see a network that uses web, you'll get stuck and you won't even be able to break into it. So, in this lecture, I'm going to explain how web works and what's the weakness that we can use to break it. And in the next lecture, you'll see how we can use this weakness in order to break web and get the key for any network that uses WEP. So basically, WEP uses an algorithm called RC4 to encrypt its data. So the way this works is basically, if a client wants to send something to the router, and let's say it wants to send this text data to send to the router, it'll first encrypt this using a key. Therefore, this normal text will be converted into gibberish, as you can see here. This encrypted packet will be sent into the air. So if a hacker captures this packet, as we've seen before, if we open this packet, we'll see that it's full of gibberish. Even though it actually contains useful information, we won't be able to read it because it's encrypted. The access point will receive this encrypted packet and it'll be able to transform it back to its original form because it has the key. Therefore, it'll actually be able to read the contents, which is data to send to the router. The same happens if the router wants to send something back to the client. It'll first encrypt it using a key, send it to the client. The client will be able to decrypt it because it has the key. So the concept is always the same. The transmitter encrypts the data using a key, sends it to the receiver. The receiver is able to decrypt it because it also has the key. Therefore, anybody who captures the packet in the middle, they will get the packet, but they won't be able to see the contents because they do not have the key. So the algorithm and the way RC4 works is actually fine. The problem is with the way that WEP implements this algorithm. And to understand this, let's zoom in a little bit more on each step. So going back to the first step, we have the client trying to send data to the router, and the data that it wants to send is data to send to the router. So in order to encrypt this, WEP tries to generate a unique key for each packet. So literally each packet that's sent into the air, it tries to create a new unique key for it. To do that, it generates a random 24-bit initialization vector. The initialization vector is then added to the password of the network, to the actual key that people use to connect to the network. This generates a key stream, and then this key stream is used to encrypt this packet and transform it into gibberish. So basically we have the key stream plus the data that we need to encrypt gives us the gibberish, and then the gibberish is sent into the air. But before sending this into the air, WEP will also append the initialization vector. This is the 24-bit random number that I said it creates in order to make sure that each packet has a unique key. The reason why it adds the initialization vector to the packet is because once the router receives this packet, it needs to be able to decrypt it. And to decrypt it, it needs the key and the IV. But the router already has the key, so there is no need to send that. Therefore, we just need to send it the IV. So, when the router receives the packet, it has the IV, it has the password or the key, so it can generate a key stream and then use that key stream to transform this gibberish into its original form and read the packet. So, if you think about what I said, you can probably guess what the weakness is. Basically, the IV is sent in plain text. So if you look at this, you can see the packet content is encrypted. So if someone captures this packet, they won't be able to read this, but they will be able to read the IV in plain text. Also, the size of the IV is only 24 bits. Now, considering the huge amount of traffic that can be generated on a Wi-Fi network, this number is not big enough, and the IVs will start getting repeated in a busy network. This makes WEP vulnerable to statistical attacks, so we can use a tool called AirCrackNG to determine the key stream once we have enough repeated IVs, and from that it will also be able to crack WEP and give us the key to the network. So from the previous lecture, we know in order to crack WEP, we need to first capture a large number of packets. This means that we'll capture a large number of IVs. The IVs, because they are short, they will be repeated. Therefore, we'll be able to use a tool called aircrack-ng to run statistical attacks and crack the web key. So we're using aerodump-ng to capture the data, and we've seen how to do this before. Then we're using aircrack-ng to analyze this data and break the key. Let's see how to do this in practice. So I already have my wireless adapter in monitor mode, and it's called Mon0. I've also already run aerodump-ng to list all the networks around me. And as you can see, I have only one network using WEP. This is called test AP3. And this is my actual network that I use every day. I've just configured it to use web to make this lecture. In order to crack WEP, we need to first capture a large number of packets. This means that we'll capture a large number of IVs. The IVs, because they are short, they will be repeated. Therefore, we'll be able to use a tool called aircrack-ng to run statistical attacks and crack the web key. So we're using aerodump-ng to capture the data, and we've seen how to do this before. Then we're using aircrack-ng to analyze this data and break the key. Let's see how to do this in practice. So I already have my wireless adapter in monitor mode, and it's called Mon0. I've also already run aerodump-ng to list all the networks around me. And as you can see, I have only one network using WEP. This is called test AP3. And this is my actual network that I use every day. I've just configured it to use web to make this lecture. The main reason why I'm targeting the network that I use daily, because like I said, for this to work, we need to capture a large number of packets, and therefore we need a busy network, a network that gets used constantly to capture a large number of packets. If the network is idle, then the process is a little bit complex, and I will cover that in the next lecture. So for now, let's focus on the simplest form, which is how to break into a busy network. So I'm going to copy the BSS ID of this network, and I'm going to run aerodump-ng against this network only. So I showed you how to do this before. I'm going to do aerodump-ng. I'm going to do --BSS ID to specify the BSS ID of the network. Then I'm going to do --channel to specify the channel of the network, and we can see it's running on number 1. And I'm going to do --write to store everything that we capture into a file, and let's call this file basic web. And then I'm going to specify my wireless adapter in monitor mode, which is Mon0. So we ran this command before in the targeted sniffing lecture. All we're doing is we're running aerodump-ng against a specific network with this MAC address, with this channel, and we're storing everything in a file called basic web. I'm gonna hit enter, and as you can see, aerodump-ng is working against my target network. And if you notice, you'll see the data in here is increasing really fast. So this is something that I told you I'll talk about it later when we were talking about aerodump-ng, because I didn't want to talk about IVs at that early stage. So basically what you see under the data column is the number of useful packets that contain a different IV that we can use in order to crack the key. So the higher this number is, the more likely we will be able to crack the key. As you can see, this number is increasing very fast because, like I said, this is a busy network that is being used at the moment by my own computers and my own devices. If yours isn't increasing fast, then don't worry, we will tackle this problem in the next lectures. So for now, we're capturing a lot of data, and this should actually be enough to crack the key. So what I'm going to do, I'm going to go down to my other terminal in here, and if we actually list the files, you'll see that we have the capture file that we specified in the right argument, and like I said, we're always interested in the .cap file. So all we have to do right now is do step 2 in here, run aircrack-ng against the file that we captured in order to crack the key. So I'm going to do aircrack-ng followed by the file name, which is basicweb01.cap. I'm going to hit enter. And as you can see, it's telling us that the key is found. So let me cancel this here. And right now, we can connect to the target network, which is called test AP3, using this ASCII password. So you can literally just copy this and paste it, or you can connect using this key. Now, in some cases, you will not see this ASCII password. That's why I'm going to show you how to connect using this key right here, because you'll always get this. So I'm going to copy this. And I'm just going to paste it here. You can paste it anywhere in a normal text editor or anywhere you want. And all you have to do is remove the colons that we see in here between the numbers. So I'm going to remove this one. I'm going to remove this one, and this. And now we can just copy this. And just to show you, I'm actually going to connect from my host machine. You can connect from Kali, but when we enabled monitor mode, we killed a lot of processes, and sometimes even after you restart these processes, getting connected to your target will be a little bit buggy. So it's best to literally just restart Kali and connect again. So just to save all of this time, I'm going to connect from here. I'm just going to click here. I'm going to connect to test AP3, and I'm going to paste the password. So I'm just going to click on show the password to show it to you. Again, the same password, we just removed the colons. I'm going to click on join. And as you can see, we managed to connect, and we can test this connection by going to Google. And perfect. As you can see, it's working, and we managed to break the WEP encryption. In the previous lecture, we seen how easy it is to crack WEP. All we had to do is capture enough data and then run aircrack-ng to crack the encryption and give me the key. Now, one problem that we could face is if the network is not busy. If it's not busy, then the number of data will be increasing very, very slowly. Therefore, we're going to have to wait for a while before we have enough data to crack the key. So let me show you an example. I'm just going to run aerodump-ng here and list all the networks around me. And you can see I have my test network, my test AP in here. It's using web. And if you look under the data, you'll see that it's at 0 and it's not increasing. And even if it's going to increase, it's going to increase very, very slowly. Which means that I'm going to have to be waiting for hours before I can crack this network. So a solution to this is to force the AP to generate new packets with new IVs. Now, before doing this, we need to associate with this network. So what I mean by associate is we need to tell this network that we want to communicate with it, because by default, access points ignore any requests they get unless the device has connected to this network or associated with it. So don't get this mixed up with connecting. We're still unable to connect to the network because we need the password to be able to connect to the network. But what we're doing right now is literally just telling the target network, look, I want to communicate with you. Don't ignore my requests. That's all we're doing. So it's something similar to what happens when you just click on the network when you want to connect to it. You still haven't put the password. You're just telling the target network, I want to communicate with you. Please don't ignore me. So in this lecture, I'm going to show you how to associate with the target network so we can communicate with it. And in the next lecture, I'm going to show you how, once associated, we can inject packets into the network and force the number of data to increase very, very quickly. First, I'm going to run arrowdump-ng against my target network, which has this BSSID. So I'm going to copy it, and we're going to use the exact same command that we've been using so far. So we're going to do arrowdump-ng --BSSID, followed by the MAC address of my target, --channel, followed by the channel which my target is running on, which is 6. And we're going to store all of this, so we're going to do --write, and we'll call this file ARP replay because that's the name of the attack. And then I'm going to put my wireless adapter in monitor mode, which is mon0. So a very simple command that we done before. We're using arrowdump-ng to capture data from a network with this MAC address running on this channel. We're storing everything in a file called ARP replay. I'm gonna hit enter, and as you can see, it's running against my target. And notice the data is increasing really slow, or it's actually not increasing at all right now. Now, to associate with this network, we're going to use a program called areplayng. So we're going to type areplayng followed by --fake auth because we want to do a fake authentication attack. We're going to put 0 because we only want to do this once. We're going to do -a to specify the MAC address of the target network. So I'm going to paste it. I've already copied it. Then we're going to do -h to specify the MAC address of my wireless adapter. And to get the MAC address of my wireless adapter, I'm going to do ifconfig. And it's the first 12 digits of the unspec field. Usually you'd see it after the ether, but when you enable monitor mode, it'll show up like so. So I'm going to copy this, and I'm going to paste it here. And I'm going to replace the minuses with colons. And that's it. It's done. And finally, I'm just going to give the name of my wireless adapter in monitor mode. So a very simple command. We're using areplayng, which is a tool that can be used to run a number of attacks. And we've seen using this with the deauthentication attack. We're telling it that we want to run a fake authentication attack. We want to do this once. We're giving it the MAC address of my target network after the A. Then I'm giving it the MAC address of my wireless adapter after the H. And finally, I'm giving it my wireless adapter in monitor mode. Now, before I run this, notice in here under the auth, we have nothing, and we don't have any clients showing up in here at the bottom. Now, if I hit enter, you can see under the auth, it's showing up as open, and you can see we have a new client here associated with the network. If you look in here, you'll see this is the MAC address of my target network, and right here is the MAC address of my wireless adapter. So right now I am associated with the target network, and if I send it anything, it's going to accept it and it's going to communicate with me. Again, I am not connected to the network. I still can't use the internet. I'm literally just associated with the network so I can communicate with it. Now, in the next lecture, I'm going to show you how we can communicate with this network in a way to force it into generating new packets with new IVs, which will allow us to crack the key very quickly. Now that we have associated with our target network, we can start communicating with it and it won't ignore us. So now we can go and start injecting packets into the traffic to force the access point to generate new packets with new IVs. This will increase the number of data really quickly, allowing us to crack WEP networks in minutes, even if the network was not busy like the one that we are targeting right now. Now, there are a number of ways to do this, but in this course, I'm going to explain the most reliable method, which is using an ARP request replay attack. I actually explain other methods in my network hacking course, but they are a little bit more complex and have less success rate. So this is the most reliable method, and it should work against most networks if you have a good signal and a good wireless adapter. So the idea behind this method is to wait for an ARP packet, and I'll talk about ARP in more details later on. So for now, just think of it as a special type of a packet that we're going to be waiting on. Once this packet is sent in the network, we're going to capture it and retransmit it. Once we do this, the router is forced to generate a new packet with a new IV. So, by repeating this process, we will be forcing the router to continuously generate new packets with new IVs. Then, once we have enough data, once we have enough IVs, we can run aircrack-ng exactly as we seen before and crack the key. So let me show you how to do this in practice. Now, as you can see, I'm already running aerodump-ng against my target network, and I have already associated with it as shown in the previous lecture. So the only thing that's left right now is to run the ARP replay attack in order to inject packets into the traffic and force the router to generate new packets and increase the number of data. To do that, we're going to use areplay-ng again, and the command is actually going to be very similar to this command right here. So I'm actually going to copy all of this because I'm lazy, and I'm going to clear this and paste the command here. Now, there are only a few things that I need to modify. First of all, I don't want to run a fake authentication attack, so I'm going to remove all of this. And I want to run an ARP replay attack. Also, this attack does not take a number, so I'm going to remove this number. And I'm also going to replace the A with a B. And we're done. So if you look at it, you'll see it's actually very similar to this command right here. We're using areplay-ng, but instead of doing a fake authentication attack, we're doing an ARP replay attack. We're giving it the MAC address of my target network after the B instead of the A. Then we're giving it the MAC address of my wireless adapter after the H, which is identical to this. And then we're giving it my wireless adapter in monitor mode. Now, I'm actually going to associate again before I do that. And then I'm going to hit enter here. And what's happening right now is my wireless adapter is waiting for an ARP packet. Once there is an ARP packet transmitted in this network, it's going to capture it and it's going to retransmit it. Once it does that, the access point will be forced to generate a new packet with a new IV, and we'll keep doing this, forcing the access point to continually generate new packets with new IVs. So you should just wait for it right now. We're literally just waiting for an ARP packet to be sent in the air. And as you can see, the number of data is increasing now very, very quickly, which means that we actually managed to capture an ARP packet. This ARP packet got retransmitted, forced the router to generate a new packet with a new IV, and we are continually doing this process, forcing the router to generate new packets with new IVs. So right now we can go ahead and run aircrack-ng to crack this network. And before I do that, I'll actually just associate one more time, and then I'm going to do aircrack-ng and give it the name of the file which we're storing the data in, which is called arpreplay01.cap. So I'm going to hit enter, and you'll notice the cracking process right now will actually require more data packets. The reason for this is I've actually modified the settings of this network so that it uses a 128-bit key, because in web you can either use a 64-bit or 128-bit key. And obviously the 128 key is longer, therefore I actually modified the key length for this lecture to make sure it's the longest key possible. And as you can see, we still managed to get it within about 47,000 packets. we have the key right here in ASCII, and we have the key in here in hex, where we can use after we remove the colons. So perfect, now we managed to crack the target network. It was idle, as you could see, there was no data being sent, and we managed to do this by forcing the target access point to generate new packets with new IVs. In the previous lectures, we've seen how to crack the WEP encryption in minutes, even if the target network is not busy. Now, in the next lectures, we will talk about cracking WPA and WPA2. First of all, before we start talking about how to crack these encryptions, it is very important to understand that both of them are very similar. The only difference between them is the encryption used to ensure message integrity. WPA uses TKIP and WPA2 uses an encryption called CCMP. In any case, this does not affect the methods that we're going to use to crack WPA and WPA2. Therefore, all of the methods that I'm going to show you from now on will work on both WPA and WPA2. Now, both of these encryptions came after WEP, and they were designed to address the weaknesses in it. Therefore, both of them are much more secure, and cracking them is more challenging. So, before we start talking about how to crack them, I want to cover a feature that, if enabled and misconfigured, can be exploited to recover the key without having to crack the actual encryption. The feature is called WPS. It allows devices to connect to the network easily without having to enter the key for the network. So it was designed to simplify the process of connecting printers and such devices. You can actually see a WPS button on most wireless enabled printers. If this button is pressed and then you press the WPS button on the router, you'll notice that the printer will connect to the router without you having to enter the key. This way, the authentication is done using an 8-digit PIN. So you can think of this as a password made up of only numbers, and the length of this password is only 8. So this actually gives us a relatively small list of possible passwords, and we can try all of these possible passwords within a relatively short time. Once we get this PIN, it can be used to recover the actual WPA or WPA2 key. So as you can see, with this method, we are not exploiting WPA or WPA2. We are actually exploiting a feature that can be enabled on these encryptions. So for this to work, first of all, we need WPS to be enabled on the network because it can be disabled. Also, it needs to be misconfigured, so it needs to be configured to use a normal PIN authentication and not a push button authentication. If push button authentication is used, then the router will refuse any pins that we try unless the WPS button is pressed on the router. Therefore, the method will not work if push button or PBC is enabled. So in most modern routers, PBC comes enabled by default or WPS will be disabled by default, so this method might not work. But because WPA and WPA2 are so secure and so challenging, it is always a good idea to check if WPS is enabled and try the method that I'm going to show you to crack the network. If it fails, then you can try the other methods that I'm going to show you after the next lecture. Okay, now that we know what WPS is and how it can be used to recover the password for WPA and WPA2 networks, let's see how to do that in practice. So, right here I have my Kali machine. I've already enabled monitor mode on my wireless adapter on Mon0. Now usually we use AeroDumpNG to see all the networks around us. But right now, we want to see the networks that have WPS enabled, but because like I said, it's just a feature and people can turn this feature off. So first of all, I'm going to use a tool called Wash to display all the networks around me that have WPS enabled. So we're going to do wash -- interface, and give it my interface in monitor mode, which is Mon0. So all we're doing is wash is the name of the tool, interface to give it the interface, and Mon0 is my wireless adapter in monitor mode. If I hit enter now, you'll see it'll list my network straight away. Now I pressed Ctrl C to cancel this, similar to aerodump-ng, because it'll keep running unless you cancel it. And you can see this is my target network. It's called test AP. It's giving us the vendor of the hardware used in this network, in this access point. The LCK tell us whether WPS is locked or not, because sometimes WPS locks after a number of failed attempts. So right now this says no, which means that we can actually go ahead and try to guess the pin. It's giving us the version of WPS. It's using version 1. The signal strength is in here, the channel, and the BSS ID. Now I explained the meaning of all of these things before in my aerodump-ng lecture, so I'm not going to talk about them now. If you forgot the meaning of any of these terms, please go back to the aerodump-ng lecture. Now this network actually uses WPA2, so just to confirm this to you, if I go here to my host machine and just try to connect to it, you'll see that it's telling me that this uses a WPA2 password. But like I said, we don't care if it's WPA or WPA2 because we're going to be exploiting a feature in these encryptions, which is the WPS feature. So now that we know our target network uses WPS, there is a good chance that this attack will work against it. The only reason it might fail is if the target uses PBC or push button authentication. Like I said, if the target uses PBC, then it will refuse all the pins unless the button is pressed on the router, and therefore this attack will fail. The only way to know is to literally try this attack and see if it works. So I'm going to copy the MAC address of this network, or the BSS ID. And the first thing that I'm going to do, similar to what we did with WEP, I'm going to associate with the target network using a fake authentication attack. So basically I'll be saying, I want to communicate with you, please don't ignore me, so that when I run the attack, the network will start accepting the pins and not ignore me. So to associate, we're going to use the exact same command that we used when we did it with WEP. So we're going to use areplay-ng. We're going to tell it I want to run a fake authentication attack. We're going to give it the delay. So this is the time to wait between association attempts. Previously we set it to 0 and we had to do this manually every now and then. Right now I'm going to set it to 30 so that we associate with the target network every 30 seconds. Then I'm going to do -A to give it the MAC address of my target, and -H to give it the MAC address of my wireless adapter in monitor mode, and we've seen that we can get this by doing ifconfig and copy it from here. We said it's the first 12 digits, and I'll just replace the minus with the colon. And finally, I'm going to give it the name of my wireless adapter in monitor mode, which is Mon0. So I explained this in details before. That's why I did it quickly. If you don't remember how I did this, please go back to the fake authentication attack lecture. So the command is ready now, but I'm not going to execute it. I'm going to go down to the bottom terminal and run Reaver, which is the program that will brute force the pin for me, and only then I will associate with the target, because otherwise areplay-ng will fail to associate with my network. So I'm going to move to this terminal right here. I'm going to clear the screen, and we're going to run Reaver, which is the program that's going to brute force the pin. So it's going to try every possible pin until it gets the right pin. Once it has the right pin, it'll use it to compute the actual WPA key. So using Reaver is very simple. It's very similar to everything we've been doing so far. So first of all, we have to type the program name, which is Reaver. Then I'm going to do --BSSID to give it the MAC address of my target network. So I'm just going to paste it. Then I'm going to do --channel and give it the channel of the target network, which is 1. Then we're going to do dash dash interface and give it my wireless adapter in monitor mode, which is mon0. So a very simple command. We're using Reaver. This is the name of the program that will do the brute forcing for us and give us the key. We're giving it the BSS ID, the MAC address of my target. We're doing dash dash channel to give it the channel that's my target is running on, and we're doing dash dash interface to give it the name of my wireless adapter in monitor mode. I'm also gonna add two more options. I'm gonna add dash VVV to show us as much information as possible. This is really helpful. If it fails or things go wrong, we'll be able to know what's happening, why things are going wrong. And I'm also gonna do dash dash no associate to tell Reaver not to associate with the target network, because we're already manually doing that in here. So Reaver can automatically do this step right here for you, but I've seen that it fails a lot. Therefore, it's actually better to do it ourselves manually here and then tell Reaver not to associate. So now I'm gonna hit enter to get Reaver to work. And I'm gonna go up to the top terminal and I'm gonna hit enter to associate with the target network, telling it please don't ignore us, so that Reaver at the bottom here can brute force the pin and try every possible pin until we get the correct pin, which we'll use to get the password. Now, as you can see, right now I'm getting an error, and this is actually a bug with the latest versions of Reaver. So if you get this bug, this means they still haven't fixed it in the latest version, so it's better to go back and use an older version. I'm gonna include an older version that works perfectly in the resources of this lecture, so you can access it from the top left of the lecture. If you tried Reaver and got this error right here, then go ahead and download this older version. Right now I already have it in my downloads right here, so you can see I'm in home downloads, and I have it right here called Reaver. So what I'm going to do is I'm going to clear this again, and I'm going to navigate to my downloads. So CD downloads, I'm going to list, and you can see we have it right here. Now it's already in green for me, but for you, you'd want to change the permissions of this file to an executable. So you'll have to do chmod +x Reaver. This will make it an executable. Once it is an executable, you can run it by doing ./ followed by its name, so Reaver. Then you can do the exact same command exactly like I just did it with the one that comes pre-installed in Kali. So I'm actually just going to go back to what I had, and I'm just going to go to the start of the command and put ./. So when we put the ./, we're basically running the file that is in the current working directory. We're running this. We're not running the normal Reaver file that is pre-installed in Kali. Then we're using all of the options exactly the same way that we were using it with the built-in one. I'm gonna hit enter. And as you can see right now, Reaver is trying the pin 1, 2, 3, 4, 5, 6, 7. And perfect. You can see the pin was actually 1, 2, 3, 4, 5, 6, 7, 0. So it's a simple pin. It actually came with this pin. So I didn't manually set this pin. My router came from the factory with WPS enabled with this pin. So like I said, this still works, but again, not against all routers. From that, it was able to discover the WPA key, which is UAU RWSXR, and the name of the router is TestAP. So I can literally go ahead and connect with this password, and I'll be able to connect to the network and see and decrypt all of the packets sent in the air. Now, if WPS is disabled on your target network, or if it's enabled but configured to use push button or PBC, then the method that I showed you in the previous lecture will not work. Therefore, you will have to go and crack the actual WPA or WPA2 encryption. And like I said, when these encryptions were designed, the developers knew about the weaknesses in WEP, and they made sure that they properly fixed these weaknesses. They actually did a pretty good job at this. Therefore, we cannot use the same method used in WEP to crack WPA and WPA2. So in WPA2, the keys are unique, they're temporary, they're much longer than what they were in WEP. Therefore, the packets sent in the air contain no information that is useful for us. So it doesn't matter, even if we capture 1 million packets, we can't use them to crack the key. The only packets that contain useful information are the handshake packets. These are 4 packets transferred between a client and the router when the client connects to the network. So, in this lecture, I'm going to show you how to capture these packets, and in the next lectures, we'll see how to use them to crack the WPA or WPA2 key. First of all, as usual, you'd want to run aerodump-ng against all the networks around you. I've already done that, and as you can see, this is my target right here. It's using WPA2, and this is the MAC address. I'm going to copy it. And the first thing we'll do is just run aerodump-ng on this network and store the data in a file, exactly the same way that we used to do it with WEP. So we're just going to do aerodump-ng --bssid and give it the bssid of my target, --channel, and give it the channel of my target, which is 1, --write, to specify a file name to store all the data that we're going to capture in. And let's call this WPA handshake, because we're going to capture the handshake. And finally, we're going to give it my wireless adapter in monitor mode, which is mon0. So, very simple command. We've done this multiple times by now. We're using aerodump-ng. We're giving it the MAC address of my target after the BSSID. I'm giving it --channel to specify the channel of my target. I'm using --write to store all the data in a file. This file will contain everything that we capture. So if we capture the handshake, it'll be in this file. And finally, I'm giving it the name of my wireless adapter in monitor mode. So now I'm going to hit enter. And as you can see, aerodump-ng is working against my target network. And right now, all we have to do is literally sit down and wait for the handshake to be captured. Like I said, the handshake is sent when a client connects to the network. So we'll literally have to sit down and wait until a new client connects to the network. Once a new client connects, we will capture the handshake, and you will see in here aerodump telling us that the handshake has been captured. Alternatively, we can use something that we learned before, which is a deauthentication attack. We know using that attack, we can disconnect a client from the network. So we can do this for a very short period of time. We can disconnect this client from the network. He will automatically connect once we stop the attack. Therefore, when he automatically connects, the handshake will be sent in the air and we will be able to capture it. This way, we will not have to sit down and wait for someone to voluntarily connect to the network. So, we've seen how to do this before, and it's going to be exactly the same command as we did it before. We used aeroplay-ng, we did --deauth, then we specified a really large number of packets to keep the client disconnected for a long period of time. This time I'm going to set this to 4 to only send 4 deauthentication packets. This way, my client will be disconnected for a very short period of time. They won't even feel that they got disconnected, but this is enough for the handshake to be sent because they will be disconnected, they will automatically connect, and when they do that, we will capture the handshake. Now, the next argument we want to set is the MAC address of my target. So we're going to do -a followed by the MAC address of my target. Then we're going to do -c followed by the MAC address of the client that we want to disconnect. So it's this client right here. I'm going to copy, paste it here, and finally we're going to give it the name of my wireless adapter in monitor mode, which is mon0. And we are done. Again, I've spent a full lecture on this command explaining what a deauthentication attack is, so if it's a bit confusing, please go back and revise that lecture. Basically, all we're doing is we're using AirPlay-NG to run a deauthentication attack to disconnect this device for a very short period of time. That's why I'm setting this to only number 4. Then I'm using -8 to specify the MAC address of my target, -C to specify the MAC address of the client connected to this network, and then I'm giving it my wireless adapter in monitor mode. Now I'm gonna hit enter and keep an eye on this side right here. You'll see the handshake will be captured in here. So we're gonna hit enter, the authentication packets are being sent, and perfect. As you can see, once the client connected again, we received the handshake. So now we can quit AeroDump-ng, so Control-C, because we have the handshake now. It is stored in the file that we set after the right option, which is called WPA handshake. And in the next lecture, I'll show you how this handshake can be used to get the key for the network. From the previous lectures, we learned that when it comes to WPA and WPA2, the only packets that contain some information that can help us with cracking the key are the handshake packets. And in the last lecture, we learned how to capture the handshake and store it in a file. Now, the handshake does not contain any information that can help us to recover or recalculate the WPA key. The information in it can only be used to check whether a password is valid or not. Therefore, what we're going to do is to create a word list, which is basically a big text file that contains a large number of passwords. Then go through this file, go through the passwords one by one, and use them with the handshake in order to check whether this password is valid or not. You can actually download ready word lists from the internet, but in this lecture I want to teach you how to create your own word list, and in the next lecture I'm going to explain to you how the word list and the handshake are used in order to recover the password, and we'll see how to do that in practice. So in this lecture we're going to learn how you create your own word list using a tool called Crunch. This is a really handy skill to have under your belt if you want to be a penetration tester, because you're going to face a lot of scenarios where a word list attack can become very handy. So using the tool is very simple. All you have to do is just put the name of the tool, and then you specify the minimum number of characters for the passwords to be generated. Then we're going to specify the maximum number of characters for the password. Then you specify the characters that you want to generate passwords from. For example, you can put all lowercase characters, all uppercase, you can put numbers, digits, or you can just specify a smaller number to make the word list smaller. You can also use the option T, which is an optional, to give a pattern. So for example, let's say that you were looking at the person while they were typing their password, and you've seen that the password will start with an A. So you can tell Crunch that the password will start with an A, and then give me all possible combination of passwords that start with an A. And after that, we use the -O option to specify the file name where the passwords are going to be stored. So we have a small little example here that will generate a list of passwords that start from 6 characters to 8 characters and contain these characters right here. So it's going to create combinations of 1, 2, 3, ABC, and the $sign. And it's going to store it in a file called word list. And these passwords are going to start with an A and end with a B. And it will generate passwords based on all possible combinations between the A and the B. So all of the generated passwords will always start with A and end with B. So let's have an example of the tool. Now the tool actually have a lot of options other than what we've seen so far. So if you just type in man crunch, you'll see all the options that you can set, and you'll see detailed description about all of these options. So it's actually really, really good. You can go ahead and spend some time to get familiar with the tool. Now I'm going to show you the example, and based on the example, you'll be able to run all of these commands. But if you want to run or create some advanced word lists, then I highly recommend that you go over this. One of the really cool options that I want to highlight is the -p option. The -p option tells Crunch to generate passwords that don't have repeating characters. For example, when you specify all lowercase characters, you specify A, B, C, D, it will start by generating passwords made of A, and then A, B, 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 and all of that. So when you do this, Crunch will actually ignore these type of passwords, and it will only create passwords that don't have any repeating characters. And that will reduce the size of the word list from the number of characters to the power of the length to the number of characters factorial. If you scroll down, you'll actually see more examples of commands and the type of word lists that will be created. So again, you can have a look on these and get yourself familiar with. Once you're done looking at the man, you can just press Q and you'll be out of it. And we're going to run our command here. So we're going to use Crunch. And again, I want to generate passwords of minimum of 6 characters and maximum of 8 characters. And I want them to contain combinations of A, B, C. And let's say the digits 1, 2. Now in here you can actually keep listing things. You can list characters, you can list uppercase characters, or even symbols if you wanted to. Once you're done with listing the characters, we're going to specify the file to save it to, and we're going to save it in a file called test.txt. So the command is very simple. It's Crunch, minimum length of the password, the maximum length of the password, followed by the characters that we want to use to generate passwords from, and then O to the file that the passwords are going to be stored in. I'm going to hit enter. And as you can see now, it's telling us that it generated 448,000 passwords approximately, and they're all stored in a file called test.txt. Now, the size of the file is 4 megabytes. And now I can open this file by doing cat test.txt. And as you can see now, we can see all the passwords that have been generated. I'm going to Control-C out of it because it's a huge file. And as you can see, it actually contains all possible combinations of ABC 1, 2. I also want to show you an example of using the -t option. So I'm going to set this to only 6 to 6, so it's only 6 characters. And we're going to use the -t option, which is the pattern option. And I'm going to tell it that I want the password to always start with an A. And then I want you to fill all possible combinations of characters between the A and the B. So I want passwords that start with an A and end with a B. And in the middle, at the @ sign, you can fill all possible combinations of ABC 1, 2. Gonna hit enter. As you can see now, the number of passwords is much less. It's only 625 passwords because I've narrowed down the possibilities of passwords. Again, if I do cat test.txt, you'll see that I have all the passwords right here. So this is it. Tool is really useful, can be used in many scenarios. I highly recommend that you spend some time with it, and also have a look on some of the existing word lists out there on the internet. Now, from the previous lectures, we learned in order to crack WPA or WPA2, we need to first capture the handshake, and second, have a word list which contains a number of passwords that we're going to try, and hopefully one of them will be the password for the target network. So right now I have both of these components, and we are ready to go and crack the password. To do this, aircrack-ng is going to unpack the handshake and extract the useful information. The MIC right here, or the message integrity code, is what's used by the access point to verify whether a password is correct or not. So it's going to separate this and put it to the side. And then it's going to use all of the other information right here combined with the first password from the word list to generate an MIC, another message integrity code. And then it's going to compare this MIC to the one that's already in the handshake. If the MIC generated using this information plus the first password is the same, then the password used to generate this MIC is the password for the network. Otherwise, this password is wrong and it'll move to the next password. Again, it'll do the same. It'll use all of this information combined with this password, generate a new MIC, compare this new MIC to the one that's already in the handshake. If it's correct, then this is the password. If it's not, then it's going to move on to the next password. And it'll keep doing this through all of the passwords in my word list. If any of them generates the right MIC, then this is the password for the network. Otherwise, we won't be able to get the password. That's why the success of this attack really depends on your word list. So, let's see how to do this in practice. Right now, I have my word list right here. It's called test.txt. And I've actually manually added my password to the end of the list right here, just so that when I run the word list against the handshake, I will actually find the password, because the word list did not contain my password by default. I also have the handshake file right here, as you can see, and all of this is in my home directory, which is my root directory. So if I do ls in here, you'll see I have the word list and the handshake file. So we're ready to run aircrack-ng. So we're going to type the name of the program as usual, followed by the name of my capture file, which is wpa-handshake01.cap. So far it's identical to the way that we used to use it with WEP. The only difference right now, because this is a WPA2 network, we have to specify a word list with the -w option. And the name of my word list is test.txt. So very simple. Aircrack is the name of my program. wpa-handshake01.cap is the name of the file that contained my handshake. And I'm using -w to specify my word list file. I'm gonna hit enter. And as you can see now, aircrack-ng is running through the word list, testing each word in the word list one by one, as shown in this diagram, calculating an MIC based on this information and the word list, and then if the MIC is correct, it's going to tell me that this is the password. Now, the speed of this depends on your processor and the size of your word list file. So if you have a huge file, obviously it'll take you longer time. There are also online services that you can try where you upload the handshake, and they have huge word lists and they have supercomputers to run through these word lists and try to give you the password. Unfortunately, I can't share their links with you, but you can easily find them on Google if you search for them. And perfect, as you can see, we managed to find the key. It's telling us the key is found, and this is the key to the network. And this is the correct key because, as you know, this is the same key that we got when we exploited the WPS feature. So now we can go ahead and connect to the network, and we'll be able to run all of the cool stuff that I'm going to teach you in the post-connection attack section. Now, this is the only practical way known so far to crack WPA and WPA2 keys. There are methods to speed up this process, so you can use the GPU for cracking because it's much faster than the CPU. That's if you have a GPU. You can also use rainbow tables. You can also pipe the word list as it's being created in Crunch to aircrack-ng. This way you can create bigger word lists without using any storage on your computer. There are also methods so that you can pause your cracking process and then come back after a while without losing your progress. But the main idea is the same. The only way right now to crack WPA and WPA2 is through a word list attack. You can use social engineering, however, to get the password using an evil twin attack where you trick one of the users to give you the password. This is actually all covered in my advanced network hacking course. The cracking using the GPU, piping crunch to aircrack NG, getting the password using an evil twin attack, and much more advanced network hacking techniques. If you're interested in that, then I highly recommend you have a look on my advanced network hacking course. Check out the bonus lecture of this course, the last lecture of this course. It contains links to all of my other courses and the comparison between them. Okay, so through all the previous lectures, we've seen all the weaknesses that can be used by hackers in order to compromise WIP, WPA, and WPA2 encrypted networks. We've seen how they can use these weaknesses to crack the password and get the actual key to the network. We also seen that attackers are able to de-authenticate or disconnect any device from any network without the need to know the key to that network. And in the previous lecture, we've seen how we can modify the settings of our routers so that we can increase the encryption of our network, increase the security of our networks so that hackers can't use the attacks and get the password. Now, in order to apply the settings that we talked about in the previous lecture, you need to be able to access the settings page for your router. Now, each router has a web page where you can modify the settings for the router, and it's usually at the IP of that router. So first of all, I'm going to check and get the IP of my computer or of my device, and I'm just going to do ifconfig lan 0. And as you can see, this is the IP of my computer. So I'm going to open my browser and I'm going to navigate to 192.168.0, and the IP of my computer was 25. Usually the IP of the router is the first IP in the subnet, so this is the subnet. At the moment it's 192.168.0, and I'm just going to add number 1 because that's the first IP in the subnet, and that will take me to the router settings page. And as you can see, it's asking me to enter a username and a password. Now, routers come in with a pre-specified username and password. You can check what's the default username and password, and then I highly recommend you change them after that. So usually it's written in the manual. So check the manual, see what's the default username and password, and then you can log in. Now, in some cases, the attacker might be doing a de-authentication attack against you, so he might be preventing you from connecting to your network wirelessly. So what you can do is you can connect to your router using a cable, using an Ethernet cable, and when you do that, then the attacker cannot use a de-authentication attack to de-authenticate you or disconnect you. So you'll be able to access your router settings using the wire, and then you can modify your security settings and change the encryption, change the password, do all the things that I recommended in the previous lecture in order to increase the security so that the attacker will not be able to attack your network and get the key. Now, the settings of each router are different. They depend on the manufacturer and even the model of the router. But usually the settings, the way that you change the settings is the same. And like 90% of the cases, the router is always at the first IP of the subnet. So all you have to do is you get your IP using ifconfig command like we did here when we got it, and it was 192.168.0.25. That's the IP of my device. And then I changed the last 25 to number 1 to the first IP, and that is the IP of my router. Now, I'm going to navigate to the wireless settings. Now, as you can see, there's a lot of settings that you can change for your network, and we're concerned with the wireless settings at the moment. So, as you can see, my wireless is enabled. You can change the name of the network, you can change the channel, and the bandwidth and all that. So I'm going to go to the security, and as you can see now, I'm using WPA encryption with WPA or WPA2 authentication, and the encryption using AES and TKIP. And if I go on WPS, you can see that the WPS is disabled, as we said now. So basically, I'm not using web, so they cannot use any of the attacks that we spoke about that allow you to crack WEP encryption. I'm using WPA, which is much more secure, and I disabled WPS, so they cannot use Reaver to determine my WPS pin and then reverse engineer my password. The only way that the hacker can access or get my password is by obtaining the handshake first and then use a word list to find my password. Now my password is very random, even though it actually doesn't use numbers or digits, just letters, but it's very random, so there is a really small chance of someone being able to guess that password. Now, there is another thing that I'd like to show you here is the access control. And using this, you can add policies. So you can add an allow policy or a deny policy. And using that is based on the MAC address. You can specify MAC addresses that you want to allow to connect to your network. You can also specify MAC addresses that you can deny from your network. So for example, you can just, if you don't have many visitors coming to the house, or if you're in a company with a specified number of computers and you want to only to allow a number of computers to connect to that network, then you can just ask the people, get their MAC addresses, the people that you want to allow, and add them in an allow list. Now, even if someone has the actual key, the right key for your network, and they don't exist in the whitelist or in the allow list, they will not be able to access the network. You can also add a deny list, which is if you want to deny a certain computer or a certain person that you think are suspicious, you can just add their MAC address in the deny list and they will not be able to connect to your network. So this is about it. As I said, the settings page usually look different. The names might be called different names, as in the names for each of these tabs. But usually the main thing is you should be able to access the router settings using the subnet IP and adding number 1, which is the first IP at the end. And if you're being attacked, if you can't connect to your network at all, then just use a cable and modify the settings like we discussed in the previous lectures. In this section, we're going to talk about post-connection attacks, so attacks that you can do after connecting to your target network. Now, it doesn't matter whether the target network is a Wi-Fi network or a wired or an Ethernet network. It really doesn't matter. As long as you gained access to this network, as long as you're able to connect to it, you'll be able to do all of the attacks that I'm going to show you in this section. Now you'll notice once connected, you can do so many cool things. So you'll be able to gather detailed information about all of the clients connected to the same network. You'll also be able to intercept data, any usernames, passwords, or any information they use on the internet. You'll be able to modify data as it's being sent in the air, so you'll be able to inject evil code and do so many cool things on the network. Now, to do all of the attacks that I'm going to show you in here, you have two options. The first option is to run the attacks against the virtual NAT network against the Windows machine. You just need to make sure that the virtual Windows machine is connected to the same NAT network as the Kali machine. Or you can run the attacks against real computers connected to your real Wi-Fi network, and you need to make sure that you have a wireless interface connected to the Kali machine, and the Kali machine needs to be connected to your target Wi-Fi network. Now, throughout this section, I'm actually going to be using both options. So I'm going to be running some attacks against the Wi-Fi network, and I'll be running some against my virtual NAT network, just to make sure that you're comfortable with running all of these attacks in different environments and in different networks. Because like I said, it doesn't really matter how you gained your access to the network. The network type doesn't really matter either, as long as you are able to connect to the target network. Now, to practice some of the attacks that we're going to learn in the future lectures, you need to have a target machine or a victim machine. So this is a computer that you're going to target and try to hack and test the attacks that we're going to learn against. So you can do this against any machine, but I highly recommend installing target machines as virtual machines. This is great because it won't break a real computer for you if you actually break something. It's also very easy to fix. Even if you have a computer that you don't care about, it's very easy to fix virtual machines. You can just remove it and reinstall it, or store a snapshot and go back to it. Now, as we all know, Windows is a very common operating system. It's used by a lot of people. So in this lecture, I'm going to show you how to install Windows 10 as a virtual machine so that we can test some of the attacks that we're going to learn in the future against it. So we'll use this machine with scenarios that mimic a normal user that is just using their Windows to browse the internet or do whatever normal people do with their machines. So Microsoft has actually released a free versions or free virtual machines of Windows that you can download and use. These are free and you're allowed to download them, and we're downloading them from Microsoft's website. So you need to go into this link to download it. As you can see here, this is the same link. So make sure you select what host operating system you have. So if you have Windows, you click on the Windows tab. If you have Mac, on the Mac, and if you have Linux, on the Linux. I have a Mac, so I clicked on the Mac tab. And from here, make sure you select Windows 10 Stable. And make sure you select the VirtualBox image. So these are all applications that allow you to install virtual machines. At the moment, we're using VirtualBox for everything, so just make sure you use the VirtualBox image. Once you do that, you will have a zip file like this one, uncompress it, and you will get this file right here. Now, this is a virtual machine, a VirtualBox virtual machine file. So I'm gonna double click it. And as you can see now, VirtualBox is asking me to import this machine, and it's already set up the settings for it right here. Now we can import it the way it is and then modify the settings. Now, as you can see here, I have my Windows installed right here, and I'm just gonna boot into it by, actually I'm gonna modify the settings first, because I remember I think it gave it 4 gigs of RAM, and I think that's too much. So I'm gonna go in to here and I'll set this to 2 gigs. And yeah, and set that okay, and I'll start it. And as you can see, Windows starting straight away. No need to install it. It's already installed and ready and given to us by Microsoft. Now, if you get asked for a password, then the password is literally password with a capital P and a 0 instead of the O, followed by an exclamation mark. Now, as you can see, we have a fully working Windows machine right here, Windows 10. So it's our second victim or target machine. Information gathering is one of the most important steps when it comes to hacking or penetration testing. If you think of it, you can't really gain access to a system if you don't have enough information about it. So for example, let's say you're connected to a network and one of the devices connected to this network is your target. Now, for you to hack into that target, first you need to discover all of the connected clients to this network, get their MAC address, their IP address, and then from there try to maybe gather more information or run some attacks in order to gain access to your target. Now, there are a number of programs that will do this for you. Examples are NetDiscover and Nmap, which do this job really well. So in this lecture, we'll start with the simpler one, which is NetDiscover, and see how to use it to quickly map the network we're connected to. And in the next lecture, I'm going to show you how to use Nmap to gather detailed information about all of the clients connected to the same network. So I have my Kali terminal in here, and if I do ifconfig, you'll see I have ETH0, it has an IP address, and like I said, this is the virtual interface created by VirtualBox when we set the Kali machine to use a NAT network. Now, I also said that this NAT network behaves exactly like an Ethernet network, and as far as the Kali machine is concerned, it thinks that it is connected to a real wired network, and as you can see in here, it's telling me that wired connected. Now, I have my virtual Windows machine right here. it is configured to use the same NAT network as the Kali machine. Remember, we're still in the network hacking section, so both you and the target machine need to be connected to the same network. So as far as these two computers are concerned, they think that they are connected to the same network. So what I want to do right now is use NetDiscover and see how we can use it to discover all devices connected to the same network. Now the method that I'm going to show you will work exactly the same whether you're using it against a virtual network like I'm doing right now, or against real network, and even if your target is a Wi-Fi or a wireless network. So all you have to do is type the name of the program, which is NetDiscover, and then type -R to specify an IP range to search for. This needs to be a range that can be accessed by you. So right now you can see that my IP is 10.0.2.16, and I can only access IPs on the same subnet. So IPs on the same subnet start at 10.0.2.0 and they would end at 10.0.2.254 because 254 is the last IP that a client can have. So my range is going to be 10.0.2.1, and I want to search for clients that might have an IP of 10.0.2.1, 10.0.2.2, 10.0.2.3, all the way up to 10.0.2.254. So instead of manually typing all of these IPs, I can just type over 24 and NetDiscover will automatically know that I'm trying to search for all of the IPs that start at 10.0.2.1 and end at 10.0.2.254. So this is a way of specifying an IP range for the whole subnet. So if I hit enter now, you'll see that NetDiscover will show me all the IPs of the devices connected to the same network, and note that the first three parts of the IPs are always the same because they are on the same subnet. And I also have the MAC addresses of these clients, and NetDiscover is also attempting to guess the device vendor. Now if I press Q, this will quit the program, and right now we have a list of all the connected clients to the same network. Now, like I said, you can also use this method to discover clients connected to the same Wi-Fi network. The only thing is, right now, if I do ifconfig, you can see that my Kali machine does not have a wireless adapter. It's not connected to a Wi-Fi network. And like I said before, you cannot access the built-in wireless card from a virtual machine. Therefore, if you want to do this or run any of the wireless attacks that we're going to see in the future against a real computer and a real wireless network, you're going to need to use a wireless adapter. Now, I'm going to include links in the description that will help you pick a good adapter that works with Kali Linux. But right now I actually have one, and I'm just going to connect it and use it just to prove to you if things work on the virtual machines connected to the virtual network, they will work exactly the same against a real network with real machines. So I'm going to connect my adapter now, and if I do ifconfig, it's still not showing up. So I'm going to connect it from my devices, USB, and click on the adapter name, and let's see if it shows up now. Perfect. As you can see, I have an adapter now called LAN 0, and what I'm gonna do is I need to connect this adapter to a Wi-Fi network first before I can discover all the connected clients to this network. So I'm gonna go to my network manager, I'm gonna click in here, and you want to click on select network, and as you can see, automatically now it actually connected to a network. But in your case, you'd want to select a network and click on connect, and then it will ask you for the password. So now I'm actually connected, and you'll see if I do ifconfig again, right now LAN 0 has an IP address. So this means that it is connected to a network, and this means that we can use it now with NetDiscover. So again, I'm going to use the exact same command that I used before just to show you and prove to you that if this works against virtual machines, it will work against real machines. And the only difference is going to be the IP. So I'm going to remove this IP. And as you can see right now, my IP is 192.168.1.8. So therefore, the range that I'm going to look for is going to start at 192.168.1.1. And I'm going to leave the over 24 here because this will tell NetDiscover that I want to start at 192.168.1.1 and finish at 192.168.254. So if I hit enter now this did not work, and I know why. In order for this to work, you actually have to disable the NAT network. So to disable the NAT network, we're going to go on devices, we're going to go on network, and we're going to uncheck the connect network adapter. So now once done with this, if we just run the exact same command again, as you can see, it's discovering all the connected clients, all their IP addresses, all their MAC addresses, and it's guessing the manufacturer. And you can see it's also discovering some Apple devices here. So as you can see, it's working perfectly using the exact same command. Now I only did this just to show you that if things work against virtual machines and against virtual networks, then they will work against real machines, because these virtual machines and virtual networks are modeled over real machines, and as far as the machines are concerned, they actually think they are real computers and real machines. The second program that we'll use for network mapping is Nmap. Now in the previous lecture we used NetDiscover, and we've seen how nice it is to quickly discover all the devices connected to our network, see their MAC address, and maybe get the vendor. Nmap takes scanning to a whole new level. It might be a little bit slower than NetDiscover, but it will show you much more information about the target. So you'll be able to see the open ports, you'll be able to see the running programs or the running services on these open ports. You'll be able to determine the computer name, the operating system running on that computer. If you're in a network, you'll be able to discover all of the connected clients. You'll be able to bypass security, bypass firewalls, and so much more. Nmap is actually a huge tool, and there are books and complete courses done just to teach Nmap. The Nmap book would actually be a really good read once you're done with this course. Now, because this tool is huge, we're not going to be able to cover all of its uses, but in this lecture I'm going to show you the basics of this tool, how to use it to discover all the connected clients and see useful information about them, and we'll actually use it more when we get to the gaining access section. We're actually going to be using Zenmap, which is the graphical user interface of Nmap. So to run it in terminal, you just have to type Zenmap, or you can find it under your applications menu. Now, as you can see, it has a very simple interface. The first thing that we see is the target input box. In here, you can put your target. You can scan any IP that you can reach, whether it's a personal computer, whether it's a server, whether it's an IP for a web server, for a website, for example, that you want to discover all the open ports and all the running services on it. Or, like what we're going to do right now, we can put a range similar to what we did with NetDiscover, and it'll scan this whole range, discover all the live IPs, all the IPs of the connected machines on the same network, and display information about them. Now we'll have a look on how to scan servers in the gaining access section. So for now, since we are still in the network hacking section, we're gonna put a range to discover all the connected clients and see useful information about them. So right now I'm actually connected to my wireless network. That's why I'm gonna specify the whole range on that network, and we've seen how to get that in the previous lecture. So it's 192.168.1.1 over 24. At the bottom, you can see the command. This is actually the Nmap command that will be executed when I hit the scan button. So like I said, Zenmap, what we're using right now, is just a graphical interface that will run this nmap command in the background and show me the results. So if you know a custom nmap command, you can put it here, or if you just want to see nmap in terminal, you can literally copy this command, paste it in terminal, and it'll give you the same results that you would get if you run it here. Alternatively, if you don't really know much about nmap and its commands, you can use one of the ready profiles in here. So in this lecture, we're actually going to be using a number of these profiles, and we'll see the difference between them in terms of speed and the information gathered. So I'm going to start with the ping scan. This is a very quick scan. It literally just pings every possible IP in the range, and if it gets a response, it'll record this response and it'll show me the devices that gave me a response, which means that these are the devices connected to the network. Now, a lot of devices do not respond to ping requests even if they are alive, so the list that you'll get in this scan might not include all the devices connected to your network. Now, once the scan is done, as you can see, we can see the list of all the connected devices in here, and in here we can also see the MAC addresses for each of these devices. We also can see the vendor. So for example, we can see that the device at 192.168.1.1 is a Cisco device. This is actually my router, and it is made by Cisco, so this is correct. So we can go ahead and start looking for exploits in this device. We can also see the 192.168.1.10 is a HTC device, and again, this is a HTC phone. This is correct. And since it's HTC, then we know that it's probably running on Android. So as you can see, we're getting more information about the connected clients. Again, we can see the 192.168.1.12 is an Apple device. So it could be a phone, a tablet, or a Mac. We can see the next device is a Dell. So again, it was a very quick scan, but as you can see, it still gave us much more information than what we got from NetDiscover. The next scan that I want to show you is the quick scan. Now this is going to be slightly slower than the ping scan, but it's going to show us more information. So right now you can see that the scan is showing us the same information that we've seen before with the ping scan, but it's also showing us the open ports on each one of the discovered devices. So it's able to discover the following ports in the router, and we can see that port 80 is open. This is actually the port used for the router settings page because it runs on a web server, so this is correct. Again, we have our Apple device here that we said it might be a phone or a computer or a tablet, but we can see now it has port 22 open. So this is a port for a service called SSH, which is designed to allow remote access to the system it's running on. Again, if you go on all the other devices, you can see all the open ports and the services running on each one of these ports. Now, in the next lecture, we'll build up on this. We'll see how to gather even more information, and you'll see how important information gathering is, because we're going to use the gathered information to hack into an iPhone that is connected to the same network. Now, in the previous lecture, we had a quick look on Zenmap and how it can be used to gather information. So in this lecture, we'll build up on that. And the main scan that I want to show you right now is the Quick Scan Plus. This scan takes the Quick Scan one step further. So first of all, it'll be slower, but it's going to show us even more information. So first, we're going to be able to see the operating system running on the discovered devices. We will also be able to see the device type, whether it's a phone or a laptop or a router. And we'll be able to discover the program and the program version running on the discovered ports. So before, for example, we were able to discover port 80 is open, but we didn't know what program is running on this port or what version of this program. Getting the exact program version is really helpful when we get to the gaining access section, and you'll see then how we can use that to exploit vulnerable services and gain full control over the computers that have these services installed. Now, straight away, when you look at the results, you'll see that we got much more information than all of the scans we ran so far. So the first thing you'll notice is the icons beside the IPs of the discovered devices. These icons represent the operating system running on these devices. So right now we have the operating system for all of the connected devices. And now it's showing us the programs running on each of the discovered ports and the versions of these programs. So for example, if we look at the 192.168.112, the Apple device, on the last scan, we knew that port 22 open and we knew that SSH is running on it, but we didn't know what version of SSH was running. Right now we can see that it's running Open SSH version 6.1. So we can go on Google and look for exploits and vulnerabilities in this specific version, and we might actually find something. We'll actually talk more about that in the gaining access section. Now, if you look at the device type, you can see that it's a media device, it's a phone. So before, we knew this is an Apple device, but we didn't know whether it's a tablet, a phone, or a MacBook. Right now we know that it is a phone. It's also discovering that it's running Apple iOS 4, 5, or 6. Now it's actually running a newer version of iOS. I'm not entirely sure. I think 9 or 10, but still it's close enough. It's telling me that it's an Apple. It's telling me that it's a phone. It's running iOS. So this is really, really good. Now if we go to the next device here, the 192.168.120, this is a Linux device, and when we ran the quick scan, we were able to identify port 80 and port 49152 open, but again, we didn't know the program running or the service version running on this port. So right now we know it's Apache HTTPD 2.2.22. It's running on Ubuntu. So again, now we have the operating system, the exact version of the service running, so we can go and look for weaknesses and exploits in this specific version. And this port, we didn't even know what service was running on it. Right now we know it's a UPnP service, and the server is Mediatomb UPnP. We have the exact version again. So again, we can go ahead and look for exploits in these specific versions, and if we discover any, we'll be able to gain full control on this computer. Again, if we go down to the 192.168.122 machine, we can see that it's running a Microsoft HTTP API on port 5357. You can also browse by the services. So from here on the left, if you click on services, you'll be able to categorize the discovered clients based on the services. So if we click on HTTP, we'll see all the clients that have a HTTP service running. If you click on SSH, we can see the Apple device here. It's the only device that has a SSH service running. So let me actually show you a quick and fun example. If we go back here to the hosts and go back to the Apple device, the 192.168.112, as I said, we know it's a phone, we know it's an Apple phone, we know that it has an SSH service installed on it, running on port 22, and we know that SSH is a service that allows you to remotely execute system commands on the computer that has the SSH service installed. Now obviously, before you can use this service, you have to use a username and a password. Once you authenticate, it'll allow you to execute system commands remotely on that computer or on that phone. Now by default, iOS devices do not have an SSH server. Usually when you jailbreak the phone or the device, it'll automatically install an SSH server, and the password for that server is set to Alpine by default. That's ALPINE. Now, since we know that this is an iPhone and it has port 22 open with Open SSH server, we know that this phone has been jailbroken. Now, since the phone is jailbroken, we know the password to log into SSH is Alpine unless the user changed it. Now, most users do not even know about this, and even the ones that know about this, like myself, are too lazy to change it. So it's always worth a try. If you discover a phone like this in the same network, it's always worth a try to go and try to connect to it with the default password. So I'm just going to go to my terminal and I'm going to try to connect to this phone using SSH. So I'm going to type SSH root, which is the username for the admin in Linux, at 192.168.112. This is the IP of the phone. I'm going to hit enter. It's asking me if I should trust this connection. I'm going to say yes. And now it's asking me for the password. And like I said, when the phone is jailbroken, the password is set to Alpine. So I'm going to type ALPINE. I'm going to hit enter. And as you can see, I logged in as root. So right now I have the highest privileges on the phone and I can do whatever I want on the system. And now we can use system commands to completely control the phone. Now this is a little bit ahead of time. We are still in the network hacking section, so don't worry too much about this. We'll talk more about it in the gaining access section, but it's just a quick example that I wanted to show you of how powerful information gathering is, because we literally did not exploit anything right here. We just relied on the information we gathered and we were able to hack an iPhone that is connected to the same network as us. Now, like I said, Nmap is a huge tool. I highly recommend you go ahead and try the other profiles in here. And like I said, once done with the course, I think the Nmap book would be a really good read. We'll also use Nmap much more in the gaining access section, and we'll see how we can use this information to gain full control over the computers using code execution vulnerabilities and so on. But in this lecture, I just wanted to give you a quick overview, and we'll build up on this as we go through the course. Now, in this lecture and the next few lectures, I want to start talking about man-in-the-middle attacks. These are attacks that we can launch only if we are able to intercept the communication between two devices. Hence the name man-in-the-middle attacks. So a normal communication would look like this, where the device is directly communicating with the entity that they want to communicate with. In a man-in-the-middle attack, the hacker would be able to place themselves in the middle of the connection, allowing them to intercept and see anything that is being transferred between the two devices. Now, there are a number of ways to achieve this. The first method that we'll cover in this course is using an ARP spoofing attack. ARP spoofing allows us to redirect the flow of packets, so instead of it flowing as shown in this diagram, it would flow through my own computer. So any requests sent and any responses received by the target computer will have to flow through the hacker computer. This means that any messages, any websites, any images, any usernames, any passwords entered by the target will have to flow through my computer. This allows me to read this information, modify it, or drop it. So as you can see, this is a very serious and very powerful attack. And the reason why it is possible is because ARP is not very secure. Now, for us to understand how this works, you need to have a basic understanding of what ARP is. ARP stands for Address Resolution Protocol, and it's a very simple protocol that allows us to link IP addresses to MAC addresses. So, for example, let's say we have a network here. We have devices A, B, C, and D. They're all connected to the same network. And we have the router here for this network. We can see that each device has an IP and a MAC address. And let's assume that device A needs to communicate with device C. Now we're also going to assume that device A knows the IP of device C, but as we know so far, in order for these devices to communicate within the same network, device A needs to know the MAC address of device C, because like we said before, the communication inside the network is carried out using the MAC address and not using the IP address. So this is a perfectly normal situation where we have a client that needs to know the MAC address of another client so that it can communicate with this client. So what this client does, it uses the ARP protocol. What do I mean by that? Basically, it sends a broadcast message. So it sends an ARP request to all the clients on the network saying, who has 10026? Now, all of these devices will ignore this packet except the one that has this IP address, which is 10026, which is device C. So all devices will not do anything, and the only device that will respond is device C, sending an ARP response. In this response, device C is gonna say, I have 10026, my MAC address is this MAC address. This way, device A will have the MAC address of device C, and now it will be able to communicate with device C and do whatever task that it wanted to do initially. So all of this communication is facilitated using the ARP protocol. Like I said, the ARP protocol is a very simple protocol. As you can see, all it has is requests and responses, and the whole point of it is so that we can link IP addresses to MAC addresses or translate IP addresses to MAC addresses. So a device can send a request asking for a MAC address, and then the device that has the MAC address would respond with its MAC address. So each computer have an ARP table which links IP addresses on the same network to their MAC addresses. So if I go on the Kali machine and do ARP-A, you can see my ARP table here, and as you can see, it's linking the router's IP to the router's MAC address. Now same if I go to the Windows machine and run my CMD and do ARP-A, you'll see again it's linking the router's IP to its MAC address. So this machine, anytime it needs to send any request to the internet, it will direct that request to this MAC address, to the MAC address that's associated with the IP of the router, which is 10021. Now, this value in here can be easily modified by exploiting the ARP protocol. So let me go back to my diagrams, and right here we have a diagram of a typical network, and you can see that normally any device that's connected to the network, if it wants to send the requests, it will send them to the router will go and send that request to the internet, wait for the response, and then forward the response to the device that requested it. So if the hacker or the victim or any other computer on the network wanted to send a request, they will send that request directly to the router. Now what we can do is we can exploit the ARP protocol and send two ARP responses, one to the gateway and one to the victim. We're gonna tell the gateway that I am at the IP of the victim, so the access point will update its ARP table and it will associate the IP of the target with my MAC address. We'll do the same with the victim, so we'll send it an ARP response. We're gonna tell it that I am at 10021. So it's going to update its ARP table and associate the IP of 10021 with my own MAC address. So the result of this, the victim is gonna think that I am the router, and the router is gonna think that I am the victim. So anytime the victim wants to send any requests, the requests will have to flow through my computer, and I'm gonna forward them to the router. And then anytime the access point or the router wants to send responses, they're gonna go to my machine because it thinks that I am the victim, and then I'm going to forward it to the victim. So as you can see, this puts me in the middle of the connection and it gives me so much power, and we'll see all the things that we can do once we become the man in the middle. Now the main reason why we can do all of this is because ARP is not secure, because first of all, clients can accept responses even if they did not send a request. So As I said before, we're going to send a response to the access point and a response to the victim, telling them that I am at a specific IP. Without them asking who am I, or without them asking for this IP, I'm just going to send a response and they're going to accept that response anyway. Not only that, but they're also not going to verify who I am. So when I say that I am at 10.0.2.7, I am clearly not at that IP because this computer is at this IP. But the access point will trust this and it'll actually update its ARP table based on the information that I send. Same goes to the victim. I'm going to tell it that I am at 10.0.2.1. It's going to trust and believe this, even though I am clearly not at this IP because the access point is at this IP. So these are the two main weaknesses with ARP protocol that allow us to run ARP spoofing attacks. Now that we know how ARP spoofing works, let's see how we can run this attack and redirect the flow of data so it flows through our device. This will allow us to intercept data and see everything sent to and from a target computer, including usernames, passwords, and so on. Now there are a number of tools that can be used to run an ARP spoofing attack. You can even build your own tool, and I cover this in my Python programming course. But in this lecture, I want to show you how to use a very simple yet reliable tool called ARP Spoof. Then, in the next lectures, we'll use a tool called man-in-the-middle-F because it has more features. Basically, the main reason why I want to cover ARP Spoof in this lecture because it is a very simple tool, but it's very reliable. It's also ported to many operating systems, including iOS and Android. Therefore, if you learn how to use it here, you'll be able to use this tool on all of the other operating systems. So, you can only use this tool to redirect the flow of data and make it flow through your computer, and then you'll have to use another tool like a packet sniffer like Wireshark to analyze this data and do more stuff with it. And we'll cover all of this later on in the course. Now, using ARP Spoof is very simple. First, we're going to have to type its name, so it's ARP Spoof. Then, we're going to do -I to specify the interface that is connected to the target network. And in my case, it's ETH0 because that's the interface that's connected to the network. So if I do ifconfig, you'll see ETH0 is the interface that's connected. Now, as you can see, I'm going to be running this attack against my virtual NAT network. You can run this attack against any type of network, even Wi-Fi networks, and I will cover that later on in the course. But for now, just until you properly understand how this works, I highly recommend you do like I'm doing right now and test the attack against the virtual NAT network. So all you'll have to do is make sure the Kali machine and the target Windows machine are both configured to use the same NAT network. So we're going to do -T to specify the target, and my target is at 10.0.2.7. As you can see in here, that's the IP of my target. And I'm going to have to give it the IP of the gateway, which is at 10.0.2.1, as you can see in here. Now this will spoof the target, telling him that I am the router. We'll also need to run this command once more in here. So I'm going to clear the screen. And again, I'm going to do ARP spoof IETH0. And the target this time is going to be 10.0.2.1 and 10.0.2.7. So right now we're going to be telling the router that I am the victim. So the first one will fool the victim, the second one will fool the router. Now keep in mind, this attack will work against both Ethernet and Wi-Fi or wireless networks. I'm running it right now against the virtual network, which acts as an Ethernet or a wired network, but the attack can be executed exactly the same against wireless networks all you have to do is connect a wireless adapter to the Kali machine, connect the adapter to the target network, and use it. So the same concept as the network scanner applies. You need to have a wireless adapter that works well with Kali, and you need to have that adapter connected to Kali and connected to the target network. So I'm gonna hit enter here, and I'm gonna hit enter here. And now if we go to the target machine and run the same command, ARPA, you're gonna see that the MAC address now for the router is different than what it was. And this is actually the MAC address of the Kali machine. So right now, this Windows machine thinks the router is at this MAC address, and every time it needs to send requests, it will send it to this MAC address, which means that they will be sent to this computer right here. Now, this computer is not a router, so when it gets requests, it's actually going to stop them from flowing and going to the router. This is a security feature in Linux. So you need to enable port forwarding so that this computer would allow packets to flow through it just like a router. Now to enable port forwarding, we're going to do echo 1 to proc sysnet IP version 4 IP forward. And as you can see, this command gets executed with no issues. And right now, this computer will still have its internet access, so we can go and browse any website we want. But all these requests are not going directly to the router, but they are going to this computer first, and then this computer is forwarding them to the router as shown in this diagram, and then when the responses come back, they're gonna go to the hacker first, and then they go to the victim. So, as you can see, a very simple tool. It allows us to redirect the flow of data so it flows through our computer, allowing us to become the man in the middle. And once we're the man in the middle, we can inject code in the browser of the target. We can steal usernames, passwords, see all the information that the person sends and receives, replace downloaded files with Trojans, and much more. In this lecture and the next few lectures, we're going to talk about a tool called Man-in-the-Middle Framework. And as the name suggests, this tool allows you to run a number of man-in-the-middle attacks. So let's run the tool, see how we use it, and we're gonna do a basic ARP poisoning attack exactly like we did in the previous video. If I do ifconfig just to show you my interfaces, you'll see that I have my ETH0 is connected to the internal network at 10.20.14.203. So I'm actually just gonna go on the Windows machine and do an ARPA to show you the MAC addresses. And you can see that we have the gateway at 10.20.14.1 and the MAC address ends with 3500. So we're going to run the ARP poisoning attack and see if the MAC address changes and if we can become the man in the middle. So to use the tool, the name of the tool is man in the middle F. So we're going to put the command first. Then we're going to tell it to do ARP poisoning. Then we're going to give it the gateway, so the IP of the router. And then we're going to give it the IP of our target. And then I'm going to give it the interface. So the command is very simple. It's man in the middle F, the name of the tool. We're doing ARP spoofing. Then you give it the gateway, and I spelled that wrong. So the IP of the router, and then you give it the IP of your target, and then you give it the interface. If you don't specify a target, it'll default to the whole network, to the whole subnet. The interface here, as I said, I'm specifying my wired virtual interface, but you can specify your wireless card if it's connected to the network. Now, before we can run this command, we need to install man-in-the-middle F because it does not come pre-installed with Kali Linux. So I'm going to go down and I'm going to open a new terminal window, and I'm just going to do apt-get update to update my sources, and then I'm going to do apt-get install man-in-the-middle F. So as we know, apt-get is the program that we use to install packages. We're telling it that we want to install a program called, or a package called, man-in-the-middle-f. I'm gonna hit enter. And now it's asking me if I really want to install all of this. I'm gonna say yes, hit enter, and it'll install it for me. Once this is done with no errors, this means man-in-the-middle-f is installed now, and I can go back and use it. So I have the command ready now, and all I'm gonna do is just press enter to run the program. And the tool is running now. Let's go to the Windows machine, do an ARPA, and see if we manage to become in the middle of the connection. So I'm gonna run ARPA again. And as you can see, the MAC address has changed to 47E9. And that is the same MAC address as the virtual interface that we have here. So it ends up with 47E9. So that means we're the man in the middle at the moment. And the tool automatically starts a sniffer for us. So instead of ARP spoof, which only places us in the middle, this tool actually starts a sniffer, which captures the data that is sent by the devices in our network. So I'm going to go to a website called vulnweb.com. And I'm just going to click on the first result. This is just a demo website to test this. I'm going to click on login to log in. And I'm just going to put the username as admin. I'll leave that. And I'll just put the password as test pass. Now keep in mind, Firefox shows this warning when you put the password through any HTTP page. So it's not because we're doing this attack. Firefox will always show this warning if the password is being sent over HTTP. And like I said, for now, we'll test this against HTTP, and in the next lecture, I'll show you how to use it with HTTPS. So I'm going to click on login, and we'll go back to Kali. And as you can see, we got all the URLs that the user clicked. So we can see that they went to vulnweb. We can see that they went to testhtml5.vulnweb.com. And if we scroll down, we can see that there was a post request sent. And we can see that the username was set to admin and the password was set to test pass. So basically we can sniff any data, including usernames and passwords entered by any computer that is connected to our network. Now everything that we did so far will only work against HTTP pages. The reason why it works against HTTP because, as we've seen, the data in HTTP is sent as plain text, so it's text that humans like us can read and understand. That's why when we're the man in the middle, we're able to read this text, and if we wanted, we're able to modify this text as we wish. Now this is obviously a problem, and this problem was fixed in HTTPS. So, as you know, most websites these days use HTTPS, and all good websites, famous websites, use HTTPS. The reason why, like I said, because it's a more secure version of HTTP, and basically the way it works is it adds an extra layer over HTTP, which is where the S comes from. So it's a secure HTTP protocol, and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, they will be able to read this data, but the data will be gibberish. It will not be readable to the person intercepting the connection. Now, HTTPS relies on TLS or SSL to encrypt the data, and this is very difficult to break. Therefore, in order to bypass this, the easiest method is to downgrade HTTPS connections to HTTP. So, since we're the man in the middle, we can check if the target is requesting a HTTPS website, and instead of giving him the HTTPS version of that website, we will give him the HTTP version. This way, the data will be sent in plain text, and we'll be able to read it exactly as I showed you in the previous lecture. To do this, we'll have to manually configure and use a tool called SSL Strip. and I show how to do this in my more advanced courses. But luckily, man-in-the-middle-f automatically configures and starts this tool for us. So before I even run man-in-the-middle-f, I'm just going to go to the target Windows machine, and we're going to go to a target website, and let's try to go to linkedin.com. And as you can see, by default, the website loads over HTTPS. So you can see the HTTPS in here. This means everything that is sent to and from this website will be encrypted. Now, what we're going to do is we're going to go back here, and I'm going to run man-in-the-middle-f using the exact same command that I ran before. Because like I said, it automatically starts SSL strip. So if I hit enter here, you'll see that it's telling us SSL strip is online. So basically, man-in-the-middle-f right now is poisoning the network and putting me in the middle of the traffic, allowing me to intercept the data sent to and from the target. And at the same time, it ran this tool, which will detect if someone is trying to access a HTTPS website and downgrade that to a normal HTTP connection. So let's see how this is going to work. I'm going to go back to my target, and before I actually go to LinkedIn, I'm going to close the tab, and I'm going to delete my browsing data because I just loaded the website. So if I load it again now, it'll load over HTTPS. So we're going to delete the browsing data and go to LinkedIn again. And as you can see, the website is not loading over HTTPS. So you can see in here, it's not saying HTTPS. This means the website is loading over normal HTTP. And if I log in, so I'm going to put a username, let's just say zaid@gmail.com, and put a password. Then I'm just going to put 123456789. Now keep in mind, Firefox shows this notification anyway, even without the attack, as long as there is an input for a password in a HTTP page, it'll show this notification. So this has nothing to do with the attack that we're running right now. So I'm going to sign in, and I'm going to go back to my attacker machine. And if we scroll up, you'll see we have the username here, which is zaid@gmail.com, and the password as 123456789. And this was posted to linkedin.com. So again, as you can see, this is identical to what happened before, and the main reason is because we downgraded the HTTPS connection to a plain HTTP connection. So when SSL strip is working, all the HTTPS connections will be downgraded to HTTP. Now, since the connections are going to be downgraded to HTTP, that means the data is going to be sent in plain text, which means that we'll be able to read all the data that's being sent, just like we usually do with HTTP. Now, there is one exception, which is websites that use HSTS. Now, HSTS is used by Facebook, PayPal, and Gmail, for example. And basically, the way this works is the browser at the victim, at the target, comes up with a hard-coded list of websites that it should only load as HTTPS. So even if we try everything that we can and try to downgrade this connection to a HTTP, the browser will just refuse to load this page, because it knows that this page has to load over HTTPS. Now, so far there isn't a practical way of bypassing HSTS. There was, but that got fixed. But I will update you as soon as there is a new way to bypass it.
In this lecture, we're going to learn what DNS spoofing is and how to perform it. DNS is basically a server that converts domain names, so www.google.com for example, to the IP address of the device where Google website is stored. And since we're the man in the middle, we can have a DNS server running on our computer and resolve DNS requests the way we want. So for example, whenever a person requests google.com, we can actually take them to another website because we're in the middle. So when they request it, we'll actually give them any other IP that we want, and then they'll see a completely different website than what they're expecting. So we can have a fake website running on our own web server and get requests, for example, from live.com to that website. We can have a website requesting the target person to download a backdoor. We can do anything we want, really, pretending to be any other website. So the possibilities are endless of what you can do with this attack. Let's go and see how we can do this. The first thing, I'm going to be redirecting people to my web server. So the web server is going to be running on my local Kali machine. You can redirect people to any web server anywhere you want, but in this video, we're redirecting them to our local web server. So to do that, we're going to start Apache web server. Comes in pre-installed with Kali. So all you have to do is service, Apache 2, start. And the web server has started. So the files for the web server are stored in var www.html. So I'm going to open my file manager and I'm going to go to var www.html. And if we open this, this is our index. So this is the page that will be displayed to people who browse our web server. Now you can have a whole complete website installed in here and it will be displayed whenever a person visits your web server. At the moment, I have a really simple page that just says a simple text just as a proof of concept. Okay, so if we go to my browser and browse to 10.20.14.203, which is my own IP address, my internal IP, if we go to it, you'll see that we can see the text here. So we're all good. Let's configure the DNS server that comes in with man-in-the-middle framework. And to do that, we're going to use LeafPad, which is just a text editor. And then we're going to go to etc, man-in-the-middle framework, man-in-the-middle.conf. Then I'm going to scroll down to where the A records are. And the A records are basically the records that are responsible to transform domain names or translate domain names to IP addresses. So we're going to be targeting live.com, and using the star is a wildcard. So basically we're saying any subdomain to live.com should be redirected to 10.20.14.203, and that's my own IP address. So you can replace this with any IP address. For example, you can put an IP address of a remote website that you have hosted on any hosting company, or you can have it redirecting to Google, for example. If you put Google's IP, any IP you put here will redirect live.com to it. So I'm going to close that and I'm going to run my command, and the command is very simple to the commands that we were running before in previous videos. The only difference is I'm going to add one extra option, which is DNS. So it's exactly the same commands: man-in-the-middle framework, ARP spoof, gateway, target, interface, and then we added one extra option, which is DNS. Gonna hit enter, and you'll see that DNS spoofing is enabled. So let's go to the target and try to go to live.com and see what happens. And as you can see, live.com, it actually uses HTTPS, and it has been redirected to our own website, saying simple text, obviously. But as I said, you can have this in here. You can install anything you want. You can ask them to download something, or you can have a fake page and steal credentials or whatever you're looking for. It can also be used to serve fake updates to the target person. For example, there is so many uses to DNS spoofing. So this is just the basic case of how you can do DNS spoofing. And then you can use it and combine it with other attacks or with other ideas to achieve really powerful attacks.
In this video, I'm going to show you how to use man-in-the-middle-f plugins. Now, before using these plugins, we have to downgrade a library called Twisted that comes pre-installed with Kali because it's not compatible with man-in-the-middle-f. So, I'm gonna first of all remove the one that's already installed by doing rm-rf usr lib python 2.7 dist packages, and the library name that we want to delete is called Twisted. As you can see, we got no errors, which means the command got executed properly. And the next step is to install the twisted version that is compatible with man in the middle F. So we're going to do this by doing pip install twisted equals 15.5.0. So all we're doing here is we're using pip, which is a package manager for Python, to install a package called twisted. So I'm going to hit enter. And as you can see, it's telling us that it's successfully installed. So now we can use man in the middle F plugins. And before doing that, I'm going to clear the screen and just run man in the middle F -- help. And as you can see, we have a number of plugins that we can use once we're the man in the middle. Now, before testing these plugins, I'd like to note that they should work against both HTTP and HTTPS. However, according to online reports, it might fail when testing against HTTPS because man in the middle F seems to have issues with injecting JavaScript in HTTPS pages. It never happened to me, I'm just going by reports. So I'm not sure if it's because man in the middle F itself or if it's because the people just did not know how to use it. Anyway, there is a more reliable method of injecting JavaScript in HTTPS pages, but it requires programming knowledge. Therefore, I only cover it in my advanced network hacking course and in my Python hacking course. If you're interested in that, then check out the bonus lecture, the last lecture of this course, for more information about these courses and a comparison between all of my other courses that you can take with this course. With that being said, let's go and test these plugins against both HTTP and HTTPS. So we can inject JavaScript code using the inject plugin, and we'll have a look on that later on in the course. We'll have a full lecture on that. We can also inject a keylogger, and we'll have a look on this later on in this lecture. And you can use the screen plugin right here to take screenshots of the loaded pages on any computer that is connected to the same network. So let's have an example of this. So what I'm going to do is I'm going to use the exact same man in the middle F command that we've always been using. And the only thing is I'm going to add -- screen to load the screenshot plugin, which will take screenshots of every loaded page. You can also add -- interval to specify the interval in seconds between screenshots, but I'm just going to keep this to the default, so the program is going to take a screenshot every 10 seconds. So I'm going to hit enter, and I'm going to go to the target computer. Now, like I said, you will get the best results if you test this against HTTP pages. Therefore, I'm going to go to a HTTP page called vulnweb.com. And I'm going to go for any of these. So let's go for test ASP. And maybe just go on the forum here. And now, if we go back to the Kali machine, it should have taken screenshots of these pages. So I'm going to go to another desktop. I'm going to open my file manager. And we're going to go to the location where man in the middle F stores the screenshots. So you can either press Ctrl and L from your keyboard, or you can click in here, not on the search, click on here on the title bar, press a /, and as you can see, you will see the path bar opening up for you. And you want to go to var log man in the middle F. And as you can see, we have the screenshots here. So if we open this, you'll see this was the page that was loaded. And if you keep going through them, you will see the other pages that we loaded. Now, let's go and see if this will work against a HTTPS pages. Like I said, it should work, and it actually works for me, but a lot of people have reported issues. So we're going to go to CNN.com. Again, this is a website that uses HTTPS by default. You'll see that it's automatically getting downgraded to normal HTTP. And when testing this, make sure you delete the browsing data before you test it, just to make sure that the web page is not going to load from the cache and from the offline data. And let's go back to the Kali machine and see if we got a screenshot of this. And sure enough, here, if we double click this one, you can see this was a screenshot of the page as it was loading. But if we wait 10 more seconds, we will actually get another one because the plugin is taking a screenshot every 10 seconds. Now, let's go back to here, and I'm going to Control-C to quit this to stop it from taking screenshots. And the next plugin that I want to show you is the JS Keylogger. So again, we're just removing the -- screen, and I'm going to type JS Keylogger. I can't really see why you'd want to use a keylogger in the page because we can just sniff the data, but in any scenario, if you ever needed to use a keylogger, then you can use it this way. And let's go to another website. So let's go back to our HTTP website, VulnWeb. And maybe let's click on the first result here. And maybe in the search, we will just search for test and see if this is, so keep in mind, I actually didn't submit anything now. So if you are sniffing, you wouldn't actually see this yet until I submit it. But if we go back here, you can see that the keylogger has captured T, TE, TES, TEST, and then it has the full word in here. So it's literally capturing every letter I type on my keyboard. Now, let's go and test this against a page that uses normal HTTPS. And let's go to CNN.com again. Now again, in the search bar, let's just type Z security test and see if this got captured. Now, as you can see, it's not there. And I think it's because the page wasn't fully loaded. So let's type something else now. So I'm going to just delete this and type test 2.2. And perfect. As you can see, we got it right here, test 2.2. So again, it's working against HTTPS, but like I said, a lot of people reported issues with it. So if you tested it, if you followed everything, if you're not seeing any errors, you can ask us in the Q&A. We'll try to help you and debug the issues. But at the end of the day, all of these plugins rely on injecting JavaScript in the loaded pages. Man in the Middle of tries to inject JavaScript in both HTTP and HTTPS, but in many cases it fails with HTTPS. If it's failing, like I said, I do cover a more reliable method in my Python course and advanced network hacking courses. So if you're interested in that, check out the bonus lecture for links to these courses and for a comparison between all of the other courses that I teach. Also, keep in mind, this will never work against websites that use HSTS. So like we said before, HSTS is used by Google and Facebook and all of these really big and popular websites. The reason why it doesn't work against these websites because modern browsers come with a list that is stored locally with websites that should only be loaded as HTTPS. So even if we try to downgrade the connection to normal HTTP, the browser will just refuse to load that website. Right now, there is no practical way of bypassing HSTS, but I will update you as soon as there is a method to do that.
In this lecture, we're going to be talking about how to inject code into the browser, into the target computer. So since we're the man in the middle and since everything flows through our device, then when someone requests a page, we can actually insert any type of code that we want into that page. Browsers can run two types of code. They can run HTML code and they can run JavaScript code. HTML code is the code responsible for the way that the page looks. So it's the code for the buttons, for the text, for the images, all of that. So it can't really be used to do anything that will allow us to gain any access to the target computer. JavaScript, on the other hand, it's a programming language that can be used to do many things, and we'll see that in future videos. In this video, we'll see how we can inject JavaScript code into the target browser. You can use the same method to inject HTML, but JavaScript is more useful. That's why we're going to use our example to inject JavaScript. So we're going to be using the same command that we always use. The only difference is we're going to insert the inject plugin. And then we have different options for injection. So there's three main options. There is the file, so you can have your code stored into a file, and you can use JS file or HTML file to inject the code stored in that particular file that you specify. Or you can use, if your code is stored online and it has a URL, then you can use that URL or that link using the JS URL or the HTML URL options. Or you can actually supply the code itself through the command using the JS payload or the HTML payload.
Now, if you think of it, what we're doing right now is exactly what we did in the previous lecture. In the previous lecture, we just loaded ready JavaScript codes. In this lecture, we're learning how to inject custom JavaScript codes. Therefore, everything I said in the previous lecture applies here. So, using man in the middle F, you should be able to run this against both HTTP and HTTPS pages, and you'll see it right now in this video. But looking at the feedback, sometimes it seems like this method is not 100% reliable when it comes to HTTPS. A much more reliable method would require you to write some Python code. Therefore, it's a little bit too complex for this course, and that's why I only covered it in my advanced network hacking course and in my Python course. So if you're interested in that, check out the bonus lecture, the last lecture of this course, for information about both of these courses and my other courses that you might be interested in. With that being said, let's go ahead and test this, and I'm going to be using the exact same command that I used in the previous lectures. Instead, I'm going to remove the screen, and we're going to use the inject plugin, and we're going to say that I want to inject a JavaScript payload, and then I'm going to give it the code that I want to inject between two double quotations. The code that I'm going to use is a very simple code that only displays a warning on the loaded page. So we're going to say alert, single quote, test, close the single quote, and close the bracket. The reason why I'm using this very simple code is just to test and see if we can actually run JavaScript code using man in the middle F. If you want to run more complex code, you can use the JavaScript file argument, which I'm going to show you later on in this lecture. So right now we're just testing, and we're just running a very simple JavaScript code that will show a message box on the target computer. So I'm going to hit enter, and we're going to go to the target browser. Like I said, let's test it first against HTTP because it's much more reliable against that. So we're just going to go to vulnweb.com. And as you can see, we're getting a message box telling us test. Now, let's test this against the HTTPS page. So let's go to cnn.com. And perfect, as you can see, we're getting the message box right here. So the JavaScript code that we wanted is getting injected in the target browser, in the target page. And as you can see, this code is actually very simple and it doesn't do anything useful, but you can look online for more useful codes that you could run on the target computer. Now, what I also want to show you, so I'm going to do Control-C here and clear the screen. What I also want to show you is how to inject code stored in a file, because sometimes if you're actually using a useful code, it's going to be long and it's going to be hard to type it right here in one command. So I'm going to open a text editor. So I'm just going to type leafpad. So we can use this command just to open the leafpad text editor. And in here, I'm going to type the code that I want to inject in the loaded pages. Again, I'm going to use a very simple code for testing. So I'm just going to say alert,
and this time I'm gonna say test2, just to know that this is a different code. So I'm gonna press Ctrl S to save it, and I'm just gonna save it in my root directory, and let's call it jscode.txt. Okay, we're gonna save this, quit it, and now if we actually just list the files, because I'm already in root, you can see I have the file right here. So we're gonna use the exact same command like we did before, but this time I'm gonna remove all of this because we're not using a JS payload, we're gonna be using a JS file. And after that, instead of giving the code, we're gonna give the full path to the location of the JavaScript file. And in my case, it's right here, it's in root, because right now we are in root. So even if I go down and open a file manager, you can see this is the file right here, so it's in my root directory. So the path is going to be /root/JSCode.txt. So again, very simple. We're loading the inject plugin. We're telling it that we want to inject code from a file, and the location of this file is this. So I'm gonna hit enter. This will run. We go to the target. I'm gonna hit enter for this, and let's go back to VulnWeb. Sorry, I went back. I didn't actually load the page, so I'm gonna refresh the page. And perfect, as you can see, the code is getting injected in the page. This is an example of injecting the code in a normal HTTP page. And let's go to cnn.com, a HTTPS page. And perfect, as you can see, it's injecting it in HTTPS pages. So as you can see, for me, it's working for both. But for some reason, I still get sometimes people telling me that they tried everything and it's not working for them. And when I tell them the more advanced method, it always works. But like I said, every time I test it, it works for me for both, for HTTP and HTTPS. And yes, like we said before, this will not work for HSTS because the browsers will literally refuse to load the page. So, using this method, like I said, you can inject any JavaScript code in any browser that is connected to the same network as you. And the cool thing about this is it works against any browser. So whether your target is using a phone, a tablet, a computer, a TV, a PlayStation, as long as their browser supports JavaScript, this will work against their browser. And in the future lectures, you'll see how we can use that to hook people to a browser exploitation framework and from there gain full control over their devices. So stay tuned.
In this video, we're gonna cover how to use man-in-the-middle-F against a real network. Man-in-the-middle-F can be used against real networks exactly the same way that we were using it against virtual networks. The only difference is you want to make sure that you specify the right IPs, the right interface, and connect to the same network that the target person is connected to. I'd also like to go over a few points that might prevent man-in-the-middle-F from working properly. So the first thing that I'm gonna do now is just do ifconfig to show you my configuration. And as you can see, I only have ETH0 right here, and it's connected to my NAT network because I configured my Kali machine to use a NAT network right here. So, first of all, the first thing that you want to do before you target a real network is make sure that that's the only network that Kali is connected to. So, the first thing that I'm going to do is I'm going to disconnect myself from this network. This is very important, and it's actually the main thing that seems to be interfering with man-in-the-middle-F. So the attack might work, but you will have DNS issues, or the target machine will experience very slow internet connection, or they'll lose their internet connection completely. So the first thing we're going to do is we're going to disconnect from this virtual network. So we're going to go to devices, we're going to go to network, and see the check right here? That means we're connected to the network because it connects the network adapter. So I'm going to click that, and that's going to disconnect me from the NAT network. So if I do ifconfig now, you'll see that ETH0 is not connected to anything right now. So I'm literally offline in the Kali machine. I can't even ping anything. As you can see, I can't even ping Google. The next thing that we need to do is connect to the same network that the target machine is connected to. And in this video right here, I'm going to be targeting this Mac machine. So it's a real computer. It's a real physical computer connected to a real physical Wi-Fi network. And the name of the network is UPC 0460916. So this is the network that I need to connect my Kali machine to so that I can attack this computer. As we mentioned before, you can't use the internal wireless card inside VirtualBox, inside virtual machines. So to connect to a Wi-Fi network, we're going to need to use an external wireless adapter. I'm going to connect my wireless adapter right now through a USB port. And then I'm going to go to Devices, USB, and connect my wireless card. That's the name of it, Atheros. Now if I do ifconfig, you'll see that I have a new interface and it's called LAN 0, and this is my wireless card. But as you can see now, this wireless card is not connected to any network. So to attack our Mac OS machine, as I said, we need to connect to the same network that it's connected to. And to do that, I'm going to go click on this arrow. I'm going to go to Wi-Fi. I'm going to go to select network. I'm going to connect to the same network that the Mac is connected to. And I'm going to put the password. Now that I'm connected, if I do ifconfig, you'll see that LAN 0 has an IP address. And notice that the first three parts of the IP address here are the same as the first three parts of the IP address in Mac OS. So if I do ifconfig here, note that the first three parts here are the same as the first three parts here. And that basically means that these two wireless cards are on the same subnet, on the same network. And now I can use LAN 0 to target this computer right here. So if we do ARPA here, notice the MAC address now. This is the right MAC address of the router. And when we run man in the middle F, this should change to the attacker's MAC address. So let's run man in the middle F exactly the same way that we used to do before. So we're going to do man in the middle F. We're going to do ARP spoof. We're going to give it the interface. And this time we're targeting a real computer, we're targeting a real network, and LAN 0 is connected to that network. So we're going to use LAN 0 for the interface instead of ETH0. Then I'm going to set the gateway, and that's usually the first IP in the subnet. So it'll be 192.168.0.1. And then I'm going to specify my target, which is the Mac machine, and it had an IP of 192.168.0.19. So again, it's exactly the same command that we did before. The only difference is we're using different arguments. We're using LAN 0 because LAN 0 is the wireless card that's connected to the target network. We're using the gateway, which is the first IP of the same IP that we have. And then we're using the target, which is this Mac machine, and we've seen it to be 192.168.0.19. I'm going to hit enter and come back here. Now, as you can see, the old MAC address of the router used to be this. Now, if we do ARPA, the MAC address should change to the Kali MAC address. But as you can see now, in this case, it still didn't change. And the reason for this is because we're actually targeting a physical computer in a physical network. So this could actually take up to 1.5 minutes for the changes to reflect. So just give it some time and then check the MAC address again. I'm also gonna go and browse to a website just so that I'll generate some traffic on my computer, on the target computer, so that it'll go ahead and update its ARP table. Now let's check again. And as you can see now, the MAC address changed to the MAC address of the attacker's one. And if we go here, you'll see that man in the middle life is sniffing data and it's capturing data that's sent by my Mac OS. Now let's go to Hotmail and log in. Now I'm going to put the username as test@hotmail.com. And I'm going to put the password as 123456. And right here, as you can see, we managed to get the email, which is test@hotmail.com, and the password, which is 123456. And again, this worked against a real computer that's connected to a real network. So the main thing to keep in mind is make sure that you're connected to the same network as the target person. If that person is connected to a Wi-Fi network, then make sure you're using an external wireless adapter and you're not using bridged, you're not using NAT, you're literally connecting through the network manager of Kali Linux. So you need to attach the wireless card and then connect from here to the target network. Also keep in mind that you should disconnect the Kali machine from the NAT network if it was connected to one by going to Devices, Network, and then uncheck this option right here. Because we want to make sure that the Kali machine is isolated, it's not connected to any network other than the target network. So right now if I do ifconfig, you'll see that ETH0 does not have any IP addresses. The only device that has an IP address and that's connected is LAN 0. Once you're done with all of that, and if you wanted to go back to using your NAT network to target other virtual machines, or if you just wanted to get your internet connection through the host machine, so if you wanted to use the NAT network again, all you have to do is just go to Devices again, go to Network, and click on Connect Network Adapter. That'll again connect your ETH0 to the NAT network and it'll allow you to use it as you were using it before. So if I do ifconfig now, you'll see that ETH0 has an IP address and it's connected again to the NAT network. In this lecture, we're going to talk about a tool called Wireshark. Wireshark is a network protocol analyzer. It's not designed for hackers and it's not designed for hacking and spying on other people on the network. It's designed for network administrators so that they can see what's happening in their network and make sure that everything is working properly and that nobody's doing anything bad or doing anything suspicious on the network. The way that Wireshark works is it allows you to select an interface and then logs all the packets or all the traffic that flows through that interface. So you're selecting an interface. It could be a wireless card, it could be a wired card on your current computer, and then it'll start logging all the information that flow through that interface. It also has a really nice graphical interface that allow you to analyze this traffic. So it allows you to filter these packets based on the protocol using them, like HTTP, TCP, and all that. It also allows you to look for certain things. For example, if you're looking for cookies or if you're looking for posts or GET requests. And it also allows you to search through these packets. You can search through the information that's stored in the packets and find the things that you're looking for. It's a really, really big tool and you need a whole course for it. So in this course, we're actually going to use it in a few lectures, just covering the basics or the things that's related to us. So the main idea here is Wireshark is not a hacking tool. It only allows you to capture the traffic that flows through your own computer, through your own interface. I'm going to use it now and it's going to become more clear to you. So I'm just going to go to Kali and we're going to start Wireshark. You can run Wireshark from the command prompt, or you can just go on all applications and type Wireshark and it'll show up right here. I'm going to click that and that's going to load the program for me. This is just a normal error. Just ignore this error. And this is the main interface of Wireshark. So first of all, you can actually just go to the file and go to the open. And in here, it'll allow you to open a file that you've already captured. So for example, if you captured packets using a different sniffer, using AeroDump, or using man-in-the-middle-f, or using T-Shark, which is the command prompt part of Wireshark. So if you captured packets using any of these programs and you stored it in a file, you can just come in here, open it, and start analyzing that file. This is really handy because sometimes you don't really want to analyze the traffic on the fly. So sometimes you just want to capture it. Sometimes you're capturing from a small laptop, or you're capturing from your phone, and you're not even at home, you're in somewhere else doing your pen test, and then you go back home and then you want to analyze what you captured, then you can store that in a file and then just come here, go to the file open, and open the file that you want to analyze. So what I want to show you here is the idea that Wireshark is not a hacking tool. It's not going to capture things happening in another device. It will only capture things that flow through your own interface. So right here we can see that we have all the interfaces in my computer. So we can see that we have ETH0, we have any, which is just any, and we have all the other ones that some of them are created by VirtualBox. So the main one here is ETH0, which is the virtual interface connected to my NAT network. And you can see that there is no traffic flowing through this. So you can see that this is constant and nothing's happening. So what I'm going to do now is I'm just going to make this a little bit smaller, and I'm going to open my browser here. And I'm just going to go to a normal website. I'm just going to go to google.com. Now, as you can see right here, you can see the traffic in ETH0 is spiking up. So there was some traffic generated through ETH0. So if we're sniffing on this, we'll be able to capture these packets that were sent over ETH0. Now what I'm going to do is I'm going to go to my Windows machine just to prove that point, and I'm going to browse the website here, and you'll see that ETH0 will not be affected, and the traffic that's generated on this Windows machine, which is in the same network as the Kali machine, it will not be captured by the Kali machine. So if I just go to Google again here, you'll see that nothing happened in ETH0. So there is no traffic flowing through this, it's still constant, and we can only capture packets that go through ETH0. So now you'll probably ask then why Wireshark is so useful. Why are we even talking about it if we can only see things that go through our own computer? Why are we talking about it? Well, we're talking about it because we've seen there is a large number of ways that you can become the man in the middle. Now, we talked about two methods to become the man in the middle. We talked about doing that using ARP spoofing. And if we create a fake access point, then we'll naturally be the man in the middle because all the requests will be sent to our computer. So when we are the man in the middle, if we start sniffing on the interface that's used to become the man in the middle, we'll be able to capture all the traffic generated by the people that we're targeting in our man in the middle attack. So if you started a fake access point, you can start sniffing on the interface that's broadcasting the signal, and you can capture all the packets sent or received to anyone who's connected to that fake access point. If you became the man in the middle using ARP spoofing, then just select the interface that you used when you launched your ARP spoofing attack. So I'm going to do this with ARP spoofing because it's quicker and easier than generating a fake access point. But again, this works in both ways. And it even works if you manage to become the man in the middle using a different method. Just make sure you select the interface that's used to launch that attack. So I'm going to do ARP spoofing. Now you can do this using ARP spoof, or you can do it using man in the middle F. So I'm just going to do it using man in the middle F. And I'm going to go and just get the IP address of this computer. So it's 10.20.14.206. So our command is going to be man in the middle F, ARP spoof, interface, which is going to be ETH0. Then we're going to specify the gateway, 10.20.14.1. And then the target, which is 10.20.14.206. So we did this command before. This will just put me as the man in the middle. It'll redirect the traffic from the computer that has the IP that's 10.20.14.206 to my computer, placing me the man in the middle. So I'm just going to run this attack quickly. Now let's go to the Windows machine and see if I do anything here, if it's going to affect the traffic in ETH0. So we'll see if Wireshark will be able to capture traffic generated by this computer. So let's write anything here. I'm just going to Google, or I'm just going to go to a different website. I'm just going to go to Bing. And if we come back here, you'll see that we have traffic being generated here. And we can see that ETH0 is actually capturing whatever that's happening in a completely different device, and a device that's not even connected to our network. This is happening because when we are the man in the middle, all the packets that's generated by the Windows device is actually being redirected to my own computer right here, to the Kali. And then Wireshark is sniffing that from the Kali machine. It's sniffing it from my own local machine. It's not sniffing it from the network. It's not sniffing it from the target computer. It's only listening on my current interface, which is ETH0, and it can capture packets that's flowing through ETH0 because man in the middle has redirected, man in the middle F has redirected the traffic of the Windows machine to flow through my computer. So again, if you're doing this with the fake access point, then just listen on the interface that you're broadcasting. If you're doing this with a real wireless network, if you're connected to your home wireless network using LAN 0, then you can just do this with LAN 0. But with ARP spoofing, you have to first redirect the traffic, then you can use Wireshark. Now this is just to show you what Wireshark is and how it works, and I just wanted to stress the idea that Wireshark is not a hacking tool. It's only a program that allows you to log packets flowing through a certain interface and then analyze these packets. So in the next video, we'll see how we can sniff and analyze packets using Wireshark. In the previous video, we seen how we can launch Wireshark, and we said that we can actually just open a file that contains packets that we already captured, and we can start analyzing them using Wireshark. In this video, I want to start sniffing packets and then generate some traffic in my Windows machine, and then we'll see how we can analyze these packets using Wireshark. So I'm already the man in the middle. As I said, you first have to be the man in the middle to use Wireshark. And then the traffic that's generated in the Windows machine is actually flowing through ETH0, as we've seen in the previous video. So before I start capturing the packets, I want to go to the options, and I just want to show you what options we can set. So first, you can see all the interfaces that you have, and you can see the traffic generated on them. And you can see ETH0 is actually generating some traffic every now and then because it's actually coming from the Windows machine, which is already in here. And now anything that we do in here, for example, if we search for anything, you'll see there's a spike coming up here because the traffic is flowing through this. So in here, you can select the interfaces that you want to start capturing on. And you can actually select more than one interface. And all you have to do is just hold the control and then click other interfaces that you want to listen on. For example, we can just click them like this. But for now, I actually only want to sniff on ETH0. Now, if we go on the output, you'll see that you have an option to store these packets somewhere. So again, if you only want to sniff and you don't want to analyze things, then you can just go on the browse and you can store the packets that you're gonna sniff somewhere, and then you can analyze them whenever you have the time at a different time. You can just open them with Wireshark like I showed you in the previous video. You can just go on File, Open, and then open the packets and start analyzing them. Now, I have ETH0 selected, and I'm just gonna click on Start. And that will start capturing packets. Anything that's going to flow through ETH0 will be captured, and it will be displayed in here. Anything. I mean, images, pictures, messages, cookies, anything that computer will flow through ETH0 and therefore will be captured by Wireshark. So it's not like Man in the Middle Life where it was only showing us the important information. Right here, you'll see anything, all the traffic that's generated. So let's first of all generate some traffic here. So we've already generated this, but this wasn't captured. So let's look for something. So for example, let's look for a car. We're just going to look for a car called GTR. Maybe we go on images. You can see some nice pictures. Maybe open one of them. Now let's go back to Bing. And let's go to Dailymotion. Okay, now let's try to analyze the packets or the traffic that we generated. So I'm just gonna stop this. Now this is the main interface of Wireshark, and you can see that the first thing we have is each one record of this is a packet. Now you'll see here the columns. First of all, here is the number of the packet. So you have this one is number 1, number 2, number 3, number 4. In the time, you'll see the time when this packet was captured. So 0 is when we first started sniffing, and then the time increases as we go down, and it shows when these packets were captured, when they were sent basically. You can also see the source. So this is the device that the packet was sent from. And you can see that this one is not sent from our target. It's actually coming from the internet, from a server that has this IP, and it's going to our target computer, which is 10.20.14.206. You can see the protocol, so it's TCP for this one. You can see that it's ICMP in this one, and you can see that it's ARP for this. You can see the length, which is the size, and you can also see info about this packet. Now you can also notice that these packets have different colors. Usually green is TCP packets, dark blue is DNS packets, and if we go down, we should actually be able to find some of them. And you can see all of these are DNS packets. Light blue usually is UDP, but we don't have any UDP packets at the moment. And you can also see that we have some black packets, and these are TCP packets that had a problem, that had issues. Now, if you double click any of these packets, it will display more information for you here. It's the same information that's being displayed in here in the bottom. So if we just bring that down a little bit, you can see right here you have the frame, you have the Ethernet, the Internet Protocol, and the Transmission Control Protocol. And using that, you can just click on the arrow and then you'll see more information that's stored in here. Now again, if you just double click the packet, you'll get the exact same information, and you'll be able to get information about the packet that you just selected. Now what we did on the target computer so far, most of the traffic that we generated was HTTP traffic. So to get rid of all this information that's hard for us to read, we're just gonna type in here in the filters, we're just gonna type in HTTP. Hit enter. And as you can see now, that filtered all the packets to HTTP traffic only. So for example, right here, you can see that we have a post request send from our target computer to a server. We still don't know what that server is, but to a server on the internet. And when we double click that, we'll get more information about this packet. I'm gonna make this smaller here. So in the frame, you can see the interface that's used. You can see information about the packet itself. In the Ethernet 2, you'll see information about the destination and the source, so you can see that the MAC address is used. In the Internet Protocol, you'll see information such as the geolocation of the target, so we can see that this packet is sent to the United States. In the transmission, you can see information about the ports used. What really interests us is the Hypertext Transfer Protocol, and this is where you really see the interesting information in our case. So in here you can see that the request was sent to Bing.com, and you can see that this request was searching for www, and you can see that the content type was a text. So you can get this information about each packet that's sent. So you can see that Wireshark logs everything that happens. It doesn't only log, or it doesn't only show the interesting stuff, it literally logs everything. So it contains the interesting stuff plus much more. Now if we go down, we can see that we have another post request, and if we double click that, it's probably going to be my second search, which is when I search for the GTR. And you can see here I searched for a car and it's called GTR. So again, right here we can see all the searches that we did. We can see all the URLs that the user entered so far. And if we go down, you'll be able to see all the other URLs that we visited. So you'll be able to see Google and Dailymotion as well. In this video, we'll see how to use more Wireshark filters and capture a username and a password. And also we'll see how to see the cookies of a person if they're already logged into a service and they didn't enter their username and password. So I'm going to start a new capture. I'm going to close this without saving. And I'm going to remove this filter from here. And I'm just going to go to Hotmail. And I'm going to log in with my username, which is zaid@hotmail.com. And then I'm going to put the password, which is going to be a random password, but it's going to be captured. So we're going to put 1234556. Hit enter. And as you can see now, we managed to capture traffic. I'm going to stop this. And I'm going to look for HTTP. And we're going to look for post requests. So we can see here we have get. These packets are sending get requests. And we're going to look for something that's sending a post request. And you can see now this is the first one sending a post request. So it's being sent from the target computer to the server. So let's double click this and see what's inside it. And looking right here, you'll see that this was sent to login.live.com, but we can't see any username and passwords in this one. So I'm going to close it. And I'm going to look for the next post packet, which is this one. Again, double click it. And let's see what's inside it. Now, if we come here to the HTML form, you'll see that we have the login, which is zaid@hotmail.com. So this is what we entered. And you can also see the password, which was sent as 123456. So again, man in the middle left was doing this very easy for us, and it was showing us the information easily. It was filtering the important information for us. But right here, we can see that we can actually capture anything that's sent on the network, and we can see it using Wireshark. Another thing that you can do is you can actually search through these whole packets. So you can just go to edit and then go to find packet, and right here you can select if you want to search in the packet list, which is just this, or in the packet details. So we're actually going to search in the packet details. We're going to keep this narrow and wide, and right here I've set this to string, so you can actually put a display filter if you want, but I'm searching for a string, which is just a normal text. And if we search for Zaid, it'll actually go straight to the packet, this packet, which contains my username. And again, if we just look at it here, or we can double click it, whichever is easier for you, you can see that we managed to capture the username, which is zaid@hotmail.com. Now you can do find next, and you'll get the next one. Find next, and again, it'll find the next one, which actually had my password in it. So again, the search right here is really useful function that will allow you to navigate through all of these packets and find what you're looking for. Now let's start a new capture and see if we can actually capture the cookies. So I'm going to again continue without saving. I'm going to go to my Windows machine, and I'm going to go to Dailymotion, which I already logged in before. And as you can see, it's not asking me to log in because I've already logged in. And it already has a name here, so I'm just gonna go to this channel. Now it's just a fake channel that I created just for this lecture. Now if we go to our Wireshark right here and stop the capture and look for, instead of HTTP, we're gonna look for http.cookie. So if we go down, you can see that right here the person got to their homepage, which is that's the username, the fake username that I had. Now if we go to the post request before that, and look at the hypertext, you can see the cookie that was sent to authenticate that person. So if you use, you can just download a plugin for your browser and inject these cookies into that browser. You'll be able to log in to that username, to that account, without using the password, the same way that the user entered. Again, I'm just doing this to show you that Wireshark can be used to do all of the attacks that we did before, plus much more, because basically it can capture anything that flows through our device. So any request sent or received to or from the target computers will be flowing through our interface, and then Wireshark will be capturing anything, regardless of whether it thinks it's important or not. It's going to capture everything. So it's a really, really handy and useful tool. Now, from the previous lectures, we know once we connect to a network, it's game over, because once connected, we can run an ARP spoofing attack to redirect the flow of packets so that they go through our computer. This allows us to become the man in the middle, and once we're the man in the middle, we can run so many dangerous and effective attacks. So we can spy on all the users, steal their passwords, redirect them to different websites, and this is all just a small taste of what you can do. You'll actually see us build on this in the client-side attack section, where we're going to completely hack into computers connected to the same network as us. And if you go and do my advanced network hacking course, then you'll see more advanced attacks that'll allow us to do so many cool stuff on the network. And again, all of this is possible because once we connect, we can run ARP spoofing and become the man in the middle. Now in this section, I actually want to show you another method that'll allow us to become the man in the middle. And once we're the man in the middle, we'll be able to run all of the attacks that you've seen so far and all of the other man in the middle attacks that you'll learn in the future. So let's go back to the first diagram that we learned in this course. When we were talking about how networks work in general, we said the only device that has access to the internet is the access point, and whenever a client wants to access something, they send the request to the access point goes to the internet, gets the response, and send it back to the client. Now, what if we replace this access point with our hacker computer? So what if we can use our machine to create a Wi-Fi network that actually has internet access, so people will actually try to come in and connect to our network to access the internet, and then when they connect to our network, by default, we will be the man in the middle because we are the router. So we won't really need to exploit anything. We are automatically the man in the middle, and the clients will automatically send us any requests because they want to access the internet, and we will see these requests, obviously, go to the internet, get them what they want, and give it back to them. This way, we'll be able to launch all of the attacks that I showed you previously without the need to exploit the ARP protocol, so without the need to run ARP spoofing. All we'll have to do once our network is running and we have clients connected, we can just start sniffing using Wireshark or using man in the middle F. So, for this to work, you need a computer, and we already have our hacker computer with Kali Linux. You also need internet access, and you need a wireless device that's going to broadcast the Wi-Fi signal and tell all the neighboring devices that I am a network, you can come in and connect to me. So, you will need, first of all, an interface that has internet connection. This interface, it can be a Wi-Fi interface connected to the internet, it could be an Ethernet interface connected to an Ethernet network, it could be a 3G or a 4G dongle, and it even can be a virtual interface, and this is what I'm actually going to do. It's going to be my ETH0, the virtual interface that is connected to my NAT network. So this can be any network device as long as it has internet access. The next interface that you will need, like I said, it's gonna have to be a Wi-Fi interface because it needs to be able to broadcast the signal for the network.
And you can't use any Wi-Fi interface. This interface needs to be able to act as an access point. So it needs to be capable of acting like a proper access point, like a router. Now, all of the Wi-Fi adapters that I recommend support this mode, and I've already included a video in the resources before when I first spoke about wireless adapters, but I'm also going to include this video in the resources of this lecture. So if you're going to buy one, or if you're not sure how to pick the right one, then check out this video. It should be helpful for you. So once we have this set up properly, we can use our computer to start an access point, and it's going to act exactly like a router. So people will be able to see the network when they look for Wi-Fi networks. They'll be able to connect to it and get internet connection. But when they connect, they will have to send us all of their requests, because we are the router, we are the access point, so by default, we will be the man in the middle. Therefore, you'll be able to execute all man-in-the-middle attacks that you learned so far, and any other man-in-the-middle attacks that you will learn in the future. So basically, ARP spoofing is one method of becoming the man in the middle, and what I'm going to show you right now is another method of becoming the man in the middle. Now, you can see that in order to use our computer as an access point, we need a number of components to be configured properly. So first of all, we need our wireless interface to broadcast the signal as if it's a real network. This will allow other clients to connect to it, but that's not the end of the road. The wireless interface needs to know when these clients are requesting websites. It needs to be able to forward these requests to the other interface that is connected to the internet. Then again, it will need to be able to know when the responses come back and forward all of this to the right client. Now you can configure all of these things manually, and I actually cover this in my advanced network hacking course, and I cover a lot of advanced things that you can do with the fake access point, like launching an evil twin attack, hacking into WPA2 Enterprise, and so on. But this would take at least 30 lectures, and this is not a network hacking course. This is a general ethical hacking course. Therefore, that would be out of the scope of this lecture. If you're interested in learning how to do this manually and how to run advanced attacks using the fake access point, then check out my advanced network hacking course in the bonus lecture, the last lecture of this course. For now, for this course, I'm going to show you a great way of quickly creating a fake access point that will allow us to become the man in the middle, similar to what's shown in this diagram. The tool that we're going to use is called Mana Toolkit, and it's basically a set of tools that allow us to automatically create a fake access point, automatically sniff data, bypass HTTPS, and so on. So the tool comes with three main start scripts. So the first one, Start Now Upstream, will allow us to start a fake access point with no internet access. So this is not really useful for us, and I will not use this in this lecture. The next one is Start Not Simple. This will start a fake access point with internet access. The third one, Start Not Full, will start a fake access point with internet access, and it will automatically start sniffing data and bypass HTTPS. Now I actually always use Start Not Simple. I never use Start Not Full because this fails a lot of the times, and we already learned how to start sniffing and bypass HTTPS using man-in-the-middle F. So you can always Start Not Simple. This will start a fake access point for you with internet access, and then you can open another terminal window, use man-in-the-middle F exactly as I showed you before, and you'll be able to sniff data and bypass HTTPS. You can also use Wireshark if you want to sniff the data and analyze them, again exactly as shown before. Now, in the next lecture, I'm going to show you how to use Mana Toolkit to create a fake access point with internet connection. Now, before doing anything, I want to show you the network settings of my Kali machine. So I'm going to select it here. I'm going to go to Settings, Network, and as you can see, it's set to use a NAT network. So now, if I go to my Kali machine and do ifconfig, we'll see we have an interface called ETH0. This interface is a virtual interface created by VirtualBox because we set this machine to use a NAT network. You can also see that this interface has an IP address, which means that it is properly connected to this NAT network, and it will provide the Kali machine with internet access as long as my host machine right here has internet access. So now on my Kali, if I go and let's say if I just go to bing.com on my browser, you'll see that I can successfully go to the website because Kali is connected to the internet through this virtual interface that is called ETH0. Now, if we go back to our diagram that shows what we need to create an access point, you can see that we need an interface that is connected to the internet. We don't care what type of interface this is, as long as this interface has internet access. So in our example, we're going to be using ETH0 to provide our fake access point with internet access. The other interface that we need, we said that this needs to be a wireless adapter that is able to act as an access point. Again, if I go back to the result of my ifconfig, you can see I already have a wireless adapter connected to this computer. It's called LAN 0. Keep in mind that this is in managed mode. It's not in monitor mode, and it is not connected to anything. So you can see it does not have an IP address. This is very, very important. It needs to be, first of all, in managed mode, and second, not connected to any network. So even if we go at the network manager in here, you can see we have wired connected. This is my ETH0, and Wi-Fi not connected. Once we have everything configured properly, we can go ahead and start the access point. But first, you'll need to install Mana Toolkit because it does not come pre-installed in Kali. We can install it using apt-get, just like Terminator and other tools. So all we have to do is just do apt-get update to update the sources. Then apt-get install Mana Toolkit. Now I have it installed, that's why it's telling me Mana is already installed. But if it's not installed, this command will install it for you. Once you have everything installed, you're ready to use Mana, and before we started, we should modify its settings. Mana's settings are stored in a text file. So to edit the settings, we're going to open this file and edit it using LeafPad, which is just a text editor. So I'm going to type LeafPad, followed by the location of the file that we want to modify. And the settings file for Mana is stored in etc mana toolkit hostapd mana.conf. So all we're doing with this command is we're using a text editor called LeafPad to open a file that is stored in this path. So when we hit enter, you'll see we have the text editor here opening the file for us. And all of these are the settings that you can modify for Mana. You can actually get a full list and a full description of all the settings that you can modify in this link. But we don't need this for now. The main thing that you need to modify is the interface. This is the interface that you want to use to broadcast the signal. So basically it is this component, and in my example this is going to be LAN 0. This is my wireless interface. so I'm keeping this the same. The next thing that you might want to modify is the SSID. This is the network name that will appear when people look for Wi-Fi networks. I'm going to keep this as internet, so when people look for networks, they will see my fake access point under this name. So I have nothing to save right now, but if you modified anything, make sure you save the file from File, Save, and then close it. And the next file that we'll need to modify is the start script. This is the file that will actually start Mana Toolkit for us. Again, we're going to use LeafPad to open and edit this file. So we're going to type LeafPad followed by the location of Mana's start script, which is in user share Mana Toolkit run mana start not simple.sh. Now in this file, there are two main things that you need to modify. The first one is the upstream interface. This is the interface that has internet access. So this is this component right here. And as we've seen before, this is ETH0 in my case. So I'm going to leave this the same. The next one, the PHY, is again the interface that is gonna broadcast the signal. So in my example, this is my wireless adapter and it is called LAN 0, not LAN 1. So I'm actually gonna modify this to LAN 0. Then I'm gonna save it, Control S, and quit it, Control Q. And that's it. We're ready to start the fake access point. And like we said before, we're going to be starting it using this script right here, the start not simple. That's why we modified it. So all we have to do is I'm going to copy this because that's its location. So in order to start it, because this ends with a .sh, we're going to do bash followed by the location of the script. So when we wanted to modify it using a text editor, we used a program called LeafPad followed by the path of the file. Right now, we don't want to modify it. We want to execute the code inside it. The code inside it is a bash script code. That's why we're saying I want to run this file using bash. Now I'm gonna hit enter. And as you can see, it's telling me that the access point is enabled and I can press enter to kill the access point, so to exit it. Now, sometimes the first time that you run this script, it will not work. It will actually give you an error. So it's a good idea to actually just run the code again, literally the same command. If it fails, if it complains about a specific error, just run the command again and it might work. If it didn't work for the second time, then ask me in the Q&A section and we will respond to you and help you fix this issue. So now let's go and try to connect to this network and see if it actually works. So right here I have a Windows machine. It's another virtual machine, but I have another wireless adapter connected to this machine. Do not test this from your host machine because the fake access point is getting its internet access from the host machine through the NAT network. So if you test this network from the host machine, the network will not work. So either test it from another virtual machine with another wireless adapter, or if you don't have another wireless adapter, then you can test it from your phone or from another laptop or any other computer within range. But do not ever test it from the host machine. So right here, I'm going to search for networks to connect to. And as you can see, I have a network called Internet. It does not use a password, so I'm just going to connect to it. As you can see, I'm connected now, and I'm going to open Firefox just to check if I have internet connection. So I'm going to go to bing.com. And as you can see, bing.com is loading, so now I actually have internet access. So now anything I do on this computer will have to be sent to the access point. If I want to access any websites, if I enter any passwords and usernames, everything is gonna go to the access point. And the access point is the hacker machine. So the hacker machine is already the man in the middle. So now you're at the same position that you would be after running an ARP spoofing attack. So you can go ahead and use Wireshark to sniff packets and analyze them, or you can go and use man in the middle F exactly as I showed you before. The only thing that you need to keep in mind when using Wireshark or man in the middle F or any other tool, you need to set the interface to the interface that is broadcasting the signal. So this is the interface that you set in the PHY option, not in the upstream. So in my case right now, this would be LAN 0, not ETH0. Also, if you're going to use man in the middle F, theoretically, you wouldn't need to use the --ARP --spoof argument, but I noticed that the tool will not work unless you add that argument, so you can add it in and you'll see that it'll work exactly as shown before.
Let's start with our first tool that we're going to use to perform ARP spoofing and man in the middle attack. Now, for this type of the attack, there are many tools out there that you can use to initiate this attack. Some of them are outdated, some of them are already pre-installed in Kali Linux. However, we're going to cover one of the most known tools, which is called BetterCap. It is a little bit harder to use, however, we're just going to cover the basics of it. So let's open up our terminal, and since this tool is not already installed in Kali Linux, we must install it first. And my advice would be for this entire section to run all the tools as a root account. Now you might be asking why? Well, we're going to perform a bunch of different networking things, and some of the networking things could require root privileges. So some of the tools might not run, some of the settings might not work if we run it as a regular user inside of our Kali Linux. So let's real quick enter the root terminal. And to install our BetterCap tool, we can simply type the command apt-get install and then BetterCap. Press enter, press Y once it asks you do you want to continue, and now we're going to wait for the BetterCap installation to finish, and then we're going to enter its framework and perform MITM attack. Okay, it has finished. Now, there are two ways that we can run this attack. We can run it as a command by specifying a file that contains all of the BetterCap commands that we want to run, or we can run it inside of the framework. Now for the first try, we're going to just type BetterCap to open the framework, and we're going to experiment with different commands in order to run this attack. And then after this, we're going to see how we can run it just from a terminal in a one-line command. Okay, so once you type BetterCap inside of your terminal, it will open the BetterCap program, it will tell you which version it is, and it will also tell us to type help for a list of the commands. So let's type help to see what options do we have, and right here we're going to see a bunch of available services that we can run with BetterCap. Most of these services are not going to run, as it says right here not running, and the only one that you will see running is events.stream. Now, you might already start to notice something interesting for us, such as, for example, this ARP spoof. We talked about ARP spoof in the previous video, and we know that this is the base of our man-in-the-middle attack. However, before we get to it, let's go a little bit up and check out the help menu. So these are the commands that we can use with BetterCap. We can type help and then some module name in order to print out more information about that specific module. We can also active, quit, sleep for a certain amount of seconds. We can set value the same way that we do inside of our MSF console. If you remember, once we set values for certain payloads, we do that using this command. So we can assume that this is something similar as an MSF console, or at least it has similar options and commands. Now let's go down to these modules, and before we actually get to this ARP spoof module, let us take a look at this net probe module. If I simply just type help and then net.probe, this will give me the help menu and the description of this module. So as it says, it will keep probing for new hosts on the network by sending UDP packets to every possible IP on the subnet. In other words, what this module will do is it will discover all of the online hosts inside of our local area network. So what we can do is we can turn that on to start network host probing in background. Let's run this command as it tells us right here. Copy this, paste it right here, and let's press enter. And we can already see that it managed to discover some of the hosts inside of my network. These are the active IP addresses right here. The next thing that we want to do is we want to type the help menu for the arp.spoof module. So just type help arp.spoof and press enter. And we also get the option as to how we can run this module. But down here we can see some additional options, or as it says right here, parameters for this module. We got arp.spoof.fullduplex, we got arp.spoof.internal, arp.spoof.targets, and arp.spoof.whitelist. In this specific scenario, we're interested in these two, so the full duplex and the targets. The full duplex, if we read the description, if this is set to true, both the targets and the gateway will be attacked, otherwise only the target. And as it says right here, if the router has ARP spoofing protections in place, this will make the attack fail. So in some networks and on some routers, this attack will not work because more and more routers nowadays are starting to implement the ARP spoofing protection. However, if it is not enabled, if the protection is not enabled, then we can perform this attack. So what we must do is we can type set arp.spoof.fullduplex to be equal to true, or just set it to true. Press enter right here. And we also want to set the targets. Now you can specify the entire subnet or the entire network, or you can do it like I'm going to do. I'm just going to select one target. And the reason why I'm selecting one target is because once you run this on the entire network, there is a lot of information going inside your terminal. And it is going really fast, so you don't even get to read it. Therefore, what I'm going to do for the purposes of this tutorial is I'm going to select the IP address of my Windows 10 machine that we're going to perform the MITM attack on. And then I'm going to set arp.spoof.targets to be equal to that IP address, just like this. Once I do this, I want to start sniffing for the network connections. And we can do that if I go up here. We can see that there is a module called net.sniff. If I type help net.sniff, it will just say that this will sniff packets from the network. And the command that we use to start it is net.sniff. But before we actually start it, let's go and check out the parameters right here. The parameter that we want to use for this attack is net.sniff.local. As it says, if this is true, it will consider packets from to this computer, otherwise it will skip them. Now, once we start the ARP spoof attack, all of the packets from our target machine will go to this computer, therefore this will be able to sniff them. Let's copy this and paste it right here. And what we want to do is we want to set this to true. After we get all of these settings ready, we can type arp.spoof and we can set this on. And we can also type net.sniff on. Press enter, and this will start sniffing packets on our Windows 10 machine. We can also see some of the queries that our Windows machine is making. And if I go and try to visit some web page, we can see that our target machine is querying Facebook. As we can see, the desktop machine initiated the request for www.facebook.com. And this will work for any other website. We can see the requests for twitter.com. And if they were to input a password to an unencrypted website, such as, for example, let's say that they want to connect to our router and go right here, and they type, for example, test and click on login. If I scroll a little bit up, we should manage to find the request where they send the password. And here it is. Here is the request where they send the password. We get the username test, and the password is a hashed value. However, we managed to get it nonetheless. It will work for any website that sends unencrypted data. For example, onto this website called vulnweb.com, if I go to first link, which is this one, and I click on login, type username admin and password test, I click on login, and for some reason it seems that it didn't manage to get it. Let's just scroll a little bit up to see whether we can find it, and here it is. Here is the packet that we sent, including the username and the password. We managed to sniff it from our Windows 10 machine. Here is the username admin and the password test. Great. This is one way that you can use BetterCap. Another way that you can use BetterCap is if I exit out of this program, it will automatically start the ARP spoof and it will restore our cache for our one targets. And the way that we can run it with a command is we can just create a file called sniff.cap. And inside of this file, we can type the commands that we typed previously, which is net.probe on. We also want to select arp.spoof.fullduplex to true in order to also spoof the target and the router. And we also want to select arp.spoof.targets to the IP address of our target machine. After that, we set the net.sniff.local to true, which means only sniff the packets that are coming from and to this machine. And then we type arp.spoof on and net.sniff on. These are all of the commands that we must run, so all we need to do is save this in a file called sniff.cap, and then we can run the command bettercap-iface, and iface stands for interface, where we need to specify the interface of our machine. Since on Kali Linux, the only active interface that I have is ETH0. Once I specify that, all I need to specify is another option, which is -caplet, and then the name of the file containing our commands. And this will do everything that we just did automatically. So if I press enter, it will set all of the settings that we did, and it will start sniffing for different connections. For example, if I go right here and try to refresh Facebook, it will sniff that request to Facebook. And this is one way that we can perform man-in-the-middle attack. In the next video, we're going to check out another tool that will allow us to perform this attack that you might actually find a little bit easier to use. So thank you for watching, and I will see you in the next video.